Hi, everybody. Welcome to the 2023 Eastern Washington Riparian Planting Symposium. Thank you. It's exciting to be in person. My name is Tori Wood. I work for Mid-Columbia Fisheries Enhancement Group, and I have taken over the role for Heather Simmons, who used to be the chair of the Populus committee. Let me slide Joe. So Populus is the Columbia Basin Riparian Planting Partnership. Populus is the group that's in charge of putting on the symposium, all the pre-symposium events that we did yesterday, sending out the newsletter, which is hopefully how a lot of you heard about the event today, and hopefully some more fun stuff in the coming years. We want to do more field trips and stuff like that. The work of Populus is really heavily supported by our partners. And we have a bunch of them, which you can see on the screen here. And as I say the names of our partners, if any representatives from these organizations or committee members are available and want to stand up for recognition, please do so. So we get a lot of support from the Washington State Department of Ecology. Thank you. Mid-Columbia Fisheries Enhancement Group. Yakima Basin Fish and Wildlife Recovery Board. Kuskoski Commons. And U.S. Fish and Wildlife. And Palouse Conservation District. So thank you all to these partners. The work of Populus would not be possible without them. I also want to take a moment to thank our 2023 sponsors. These sponsors for the symposium have donated and made today's event possible. So please give a round of applause to Snake River Salmon Recovery Board. And if any of our sponsors are here too and want to stand up and wave, please do so. Washington Conservation Commission. And WildLands Incorporated. So thank you all again for sponsoring this year's symposium. They help make sure that we have snacks and a good venue for you guys and all kinds of good stuff. So thank you again. One more round of applause for our sponsors and our partners. Super quick housekeeping stuff. We have posted in various locations a QR code that you can scan if you would like to see the agenda. We've got our bios for our speakers in there, as well as some information on our sponsors and our partners listed in there. So look around for those. Like I said, they've been kind of posted around the room, and you can find any Mid-Columbia people if you need help finding them. We have a super jam-packed agenda today. So in just a moment, I'm going to introduce our first 4 speakers. And then all of those presenters are going to be going before lunch. We will have 2 speakers, a 10-minute break, and then a lunch break. And then after lunch, I will introduce the remaining speakers. So without further ado, I'm going to start introducing our first 4 presenters. Okay, so our first presentation is from Katrina Strathman, and she is doing 2 presentations for us, so one before lunch and one after. And Katrina is a restoration ecologist with 25 years of experience managing restoration projects in a variety of habitats. She is part of the team of Mid-Columbia Fisheries Enhancement Group, a nonprofit focused on protecting and restoring native salmonids across 4 counties in South Central Washington. Her current passion is riparian forest restoration and using new techniques that improve establishment or are effective over large floodplain areas. Katrina brings to her work her experience managing landscape scale inventories, studies testing restoration techniques, implementation and effectiveness monitoring for vegetation restoration, invasive plant and rare plant management, and native plant propagation. Katrina's work on ecological restoration includes 8 years with the Yakima Nation and 8 years with the National Park Service. She received her Master's of Science in Biology from San Francisco State University. Thank you, Katrina. Our next presenter is Michael Russo. Michael Russo is the Beaver Dam Analog Habitat Coordinator for Trout Unlimited's Wenatchee-Entiat Beaver Project. Michael started working seasonally for the Wenatchee-Entiat Beaver Project in 2021 and was hired on full-time in the fall of 2022. He is passionate about enhancing... Sorry, I just realized I was like, wait, am I on the right slide? I'm doing good. He is passionate about enhancing stream systems through beaver relocation and low-tech process-based restoration. The Wenatchee-Entiat Beaver Project works to reduce human-beaver conflict and build beaver dam analogs in Chelan and Douglas counties. Through beaver-powered restoration, the project is conserving and preserving important riparian habitats. Okay, thank you, Michael. Okay. Uh-oh, did I go one? Can you go back one? There we go. Thank you. Okay, so up next we have Scott Nicolai, and Samantha Bango is not able to join us today, but played a big role in putting together the presentation and a lot of the stuff that's going to be covered in it with Scott. Samantha Bango is passionate about water resource management and the impacts of low-tech solutions. She currently manages stream restoration field crews for Anabranch Solutions all over the American West. Prior to joining Anabranch, Sam conducted undergraduate research on low-tech structures, managed pollinator programs in Central Oregon, and spent a few years living in South America. These days, you can find Sam climbing up riverbanks, falling down dams, and trying her best to imitate nature's best engineers, North American beavers. When she's not conducting field work, Sam spends her free time mountain biking, backcountry skiing, backpacking, and finding vistas to watch beaver colonies work. Scott is a father, grandfather, husband, teacher, and learner. As a youth, he found peace wandering the woods of Western Washington. After high school, Scott worked in residential construction and eventually as a middle school science teacher. His career with the Yakima Nation Fisheries spanned almost 3 decades, where he was involved in all aspects of fish habitat management. He also volunteers with a local fraternal organization where he is helping to design and construct an affordable housing project. Scott's other passions involve hiking, cycling, tinkering in his woodshop, and most importantly, getting his granddaughter to smile as often as possible. Thank you to Scott and Samantha. Okay, and then our last presenter before lunch is going to be, It's going to be Alexa Whipple. Alexa Whipple is unable to join us in person, so we had a last minute switcheroo, and we're going to try and do it on Zoom. So thank you all for your patience as we figure that out. And thank you to Alexa for being willing to be super flexible. So Alexa is a restoration ecologist, a collaborator, and the project director for the Methow Beaver Project. She works for sustainability in all practices and effective process-based solutions to challenging environmental conditions. She's called the Methow and Okanogan River watersheds home for the last 22 years, but has worked across the Western U.S. studying songbirds, carnivores, plant communities, agricultural practices that sustain habitat and wildlife, and post-wildfire recovery of Western riverscapes. Alexa completed her BS in wildlife biology at Virginia Tech and MS in restoration ecology at Eastern Washington University, where she focused on beaver ecology and beaver-mediated restoration of legacy degraded and wildfire-impacted streams in the Methow watershed. Thank you, Alexa. Okay, and with that, please join me in welcoming our first presenter, Katrina Strathman.
So what I'm going to be talking about today is cottonwood ecology, but also the status of cottonwoods in one reach of the Yakima River. And my hope is to help us all to see cottonwood forests a little bit differently, and as part of the processes of, and intimately tied to the processes of the rivers and streams that we're working on as riparian ecologists and restoration ecologists. So with that, I will get started. So what I'm going to talk about today is give you a little bit of an overview of riparian function. I think we're almost all on the same page with that, and talk a little bit about cottonwood ecology, and then really hone in on in what we now know about cottonwood forests and the status of cottonwood forests on the Kittitas reach of the Yakima River. And then if I talk fast enough and don't get lost in the interesting parts of this presentation, then I'd like to also share with you some of our some restoration, share the kind of an overview of restoration techniques that we can use to support cottonwood forest regeneration. Okay, this looks a little bit blown out to me. Are you guys able to see this where you're sitting? Does this look okay? Thumbs up, maybe, and I'm getting a nod. Okay, thank you. I can't really see it where I'm standing. So this is our Mid-Columbia Fisheries 5-county reach, and I don't think I have a pointer to kind of show you where we're at. But the area that we're going to be, Mid-Columbia Fisheries, I guess I should start by saying, is a nonprofit that we work with landowners, both public and private, and our goal is to engage private citizens in the recovery of T&E fish species, both through conservation and restoration. And so we work in these 5 counties, and the area that I'm going to be talking about today is the Kittitas reach of the Yakima Basin of the Yakima River, and that's where we're at right now in Ellensburg, in Kittitas County, which is the upper reach of the river, like up there with my non-existent pointer. Okay, so this is the part of my presentation that is probably familiar to almost everybody in the room, but just to make sure that we're all on the same page. So we're talking about cottonwood because it's the dominant tree species in the arid West, and as such is a foundational species, really kind of setting process. And as you'll see, kind of maintaining its own processes in river situations. We like it for a number of reasons, including the dense root masses that slow down bank erosion, the floodplain roughness, the stem densities that slow water velocities and help sediment to drop out on floodplains. Of course, the massive canopies that help to keep cool water cool as it's moving down from our tributaries. Leaf litter and wood debris, we can't forget, really are an important piece of the food web, both for fish and for wildlife. And then one of the things that I think is the coolest piece of cottonwood ecology is that it's a source of large wood, which not only really is important in maintaining complex in-stream habitat for fish, but which is responsible for creating bars, which then are the recruitment sites for future forest stands. So really its processes help to maintain itself. So you're looking here at an image of the Big Wood River in Idaho in flood, and it's illustrating how these cottonwood have fallen in the river and are starting to erode gravels and sediment, creating their bars, scour pools, and helping the river to meander and push water to one side or the other. And as we all know, river meanders and erosion and deposition are natural processes. They don't just happen in flood; they happen throughout the year, and I think that's really key. So, at any rate, I know I'm preaching to the choir here. Okay, so honing in on cottonwood, cottonwood reproduce sexually and vegetatively. So sexually are important because those are new genetic individuals, and they, in their sexual reproduction, they have both male flowers and female flowers. This picture is showing a female catkin, so it's a fertilized female flower that pops open like this image here, and releases in the early summer months. That seed is only viable for up to a week when it's dry, but when it hits a moist substrate, it's only viable for about 24 hours. So it really needs to land in the right environment. It doesn't get to move to a new environment. It's not like a larger bodied seed that maybe could be carried by an animal and deposited somewhere. In terms of sexual reproduction, that's really important for maintaining existing stands. The important takeaway in terms of the sexual versus vegetative is that new stands are created through sexual reproduction. So if we don't have sexual reproduction happening, we're not creating new forests. Vegetative reproduction maintains existing forests. So if we don't want that forest to become decadent and eventually disappear, because cottonwood, like us, will have finite lifespans. So if we don't have new genetic or new clonal individuals created, then eventually those stands will be gone. And that occurs within stands and gaps like this one here, where you can see the seedlings or saplings kind of popping up through clonal reproduction in the middle or on the margins of stands. Okay, so in terms of the sexual reproduction, which is the thing that I'm really interested in, what is happening with cottonwood and in terms of maintaining our forests, there are several key elements that are required for cottonwood reproduction. The first is a disturbance event, usually a high flow flood event, winter or spring flood, that is big enough to mobilize sediment and create new bars. So it needs to either scour material off of bars and leave bare soil or sediment, or it creates and deposits new bars. And then the second thing is that there needs to be a flow event that happens just prior to seed release that wets up that new recruitment service that was created, that new bar or floodplain margin or channel margin. And then, so it needs to be wet at the time of seed release, and then you need a flow recession. So you need a drop off in flow that happens at a rate that new seedling roots can keep up with the growth. The seedling growth rate of roots is not slower than the rate of flow recession. I think I said that right. And then you need the final thing is that is kind of stochastic in why we don't have recruitment every single year, is that those seedlings that are lucky enough to make it onto that wet spot that got wetted up, you had a scour year, a year where new depositional surfaces were created, and then you had that flow happening in the spring at the right time. And then you also need to escape, those seedlings need to escape scour in the following couple of years. So that means that after we have a recruitment event, we need 1 or 2 winter seasons that don't also have really big years that aren't going to remove those new seedlings. So here we're looking at another way of, this is a stylized hydrograph that is showing us these same events. So first you've got, so in the blue line, a hydrograph is a water year graph. So on the y-axis, you've got the relative elevation of water relative to bank elevation across the growing season. And the blue line represents where water flow is at, or what the elevation of the water is at. So you see that we've got this peak flow happening, a flood flow, a scouring event flow that then drops off. And we have a recession limb. So this is the scour event, a recession of water that is wetting up those created bars at the time of seed release. So this recruitment box is this kind of space and time biological event combined with process that was coined by John Stella and his colleagues. for recruitment box being that peak recruitment event space. And then this flow recession slows down so that as the roots are starting to grow and at the rate of up to 2 inches a day, which is pretty astounding, we don't have flow recession happening at a greater rate than that 2 inches a day. Okay, so what does this look like on the landscape? Here is the lower Neches River, which is also a semi-regulated river, but the flow regime approximates normal and normative flow a lot closer than the Yakima River. So I wanted to show you these current era images. Oh, I do have a cursor. That's wonderful. So one of the main things that that I wanted to illustrate here is just kind of the shagginess of an active floodplain. And I don't know if you can see it on this image. Again, I'm having trouble seeing the slides from way up here. But we did, looking at aerial images, we were able to approximate the year or the period of establishment. And we can see that there were stands that established in these bands, arcing bands along the floodplain margin that are 30 years old or plus, maybe some that are 20 years old or 5 years old, 10 years old, but they're not one big solid green mass. They're many different ages. And I think that because we have a lot of decadent, mature stands out there, we forget what a healthy floodplain looks like. It's very messy. It's not all one age. Here's what it looks like, maybe looking at it horizontally. Our 5 to 10 year seedlings, saplings are in front. We've got some probably 15 to 25-year-old plants here, and then mature stands in back. So the newest ones are closest to the channel margin, having just been created as that bar, point bars, or as bars are being created as the river migrates. Okay, so we know that in our area, cottonwood live for 100, 120 years, and we know, like many organisms, that seedlings should dominate the age classes. We should have more young plants than old plants. This graph on the left is an age class distribution from a study in Alberta, a river not too unlike the Yakima River, and that shows that we've got about 80% of our plants are in the 5 to 10 year age range. Remember that number when I show you what's really going on in Yakima, in the Kittitas Reach. So I started getting involved in this when I was made aware of a study by Brotney and his colleagues that happened in the early 2000s. And they, in looking at what was happening with regeneration, on 3 reaches of the Yakima River, found few to no recruiting trees that were younger than 20 years old. So this is obviously a huge red flag of what's happening if we're not creating new stands. So we, the Yakima Nation, did some work in the Wapato Reach, and simultaneously Mid-Columbia and the Yakima Nation did some work in the Kittitas Reach. So we also started looking at when is our recruitment period happening, and we've been collecting data for the last 2 years. So in 2021, we had about a 3-week release period in June, and then in 2022, where we had that cool, moist spring, that release period was like 5 weeks long or so. That was shifted a little bit back. So we're trying to create basically a degree day model so that we can that will help us in future management that I'll get to. I may have time to get to later. So I show you that because I wanted to look at what's actually going on in the Kittitas Reach of the Yakima River. So this is a hydrograph that shows in black a modeled flow regime. It's the modeled unregulated flow at the Cle Elum release on the Cle Elum on the Yakima River. And what's important about this hydrograph is that, so this is imagining, or not imagining, but it's modeling what flow might be like if we weren't doing flow releases and if the dams weren't on the reservoirs. So in this, oops, sorry about that. In this model, our peak, we have and this, again, this is averaged over 30 years. So you're not looking at the annual peaks. So there are going to be some high highs that are all tamped down in this hydrograph. But so we've got our scour, right? And then we have our recession limb that falls into our recruitment box down to base flow. In blue, that is what is our actual 30-year average. So we have, what we're seeing is that we have even more tamped down flood flows. Are at recruitment, after seed release, we then have an increase in flows for irrigation. So the Yakima River in the Kittitas Reach bumps up, which, as you can imagine, then inundates most of the seedlings that maybe had a chance to recruit episodically. So that's a really big challenge for us, combined with a super steep, maybe 2-week-long drop-off in flow as we for irrigation management. Okay, real quick, just an image of what kind of, again, the messy, shaggy forests of pre-regulation and pre-infrastructure. And now in 2018, we're starting to see that these stands are maturing and we're not really getting as much recruitment. There are a couple of areas of like tiny bars, but I think it's really important to like look at the size of the recruitment surfaces that we've got in these kind of bright white blown out areas in the aerial image. Okay, so then we put together an assessment that was funded by the Salmon Recovery Funding Board to look at what is actually happening on the Kittitas Reach. So our first question was, what's the extent of riparian forest? And we contracted with Natural Systems Design to help us answer these questions. A geomorphologist with NSD characterized the channel migration zone in terms of different elevation surfaces using a relative elevation map. So those were characterized as developing floodplain, which essentially included the low flow channels, these gravel bars, vegetated and unvegetated, the side channels, and then established floodplain, which is, so the developing floodplain is accessed by annual floods. But the established floodplain may only be accessed by floods, say on a 10 to 20 year return interval, and terraces and disconnected floodplain. Okay, so that's what this looked like. These green areas and these tiny little light blue and gray areas right along the river, those are all of the developing floodplain. And the green is the established floodplain. Everything in this hatched is disconnected. So that's either a high terrace or a levee that has disconnected. So these are still within the 100-year flood, some of them, but they're not getting accessed by floods frequently. Our sampling area, which is really important as I show you the results of our assessment, was only within the developing and the established floodplain. So only within this narrow green band where we've got active active channel processes. So what I want to show you is kind of the best of conditions, of forest conditions. So it's not extrapolated to anything that's going on in the forest in these disconnected areas. Okay, so in terms of forest extent, by looking at those, the digitized geomorphic surfaces, we have, of areas in the channel migration zone, only 11% are developing or established floodplain, and about 30% of the CMZ is disconnected floodplain, either because it's terraces or because of human infrastructure. so roads, levees, etc. We also looked at the forest extent by characterizing it as mature forest, meaning closed or open forest, compared to scrub, shrub, developing forest. So 60% of our forests are currently mature in the CMZ. So we're not just talking about the areas where we actually looked at individual trees. We also wanted to know of the forests that are out there, what is our regeneration? What does regeneration look like? So we sampled almost 50 areas along the river, and we're able to create basically an age DBH model. And the important thing about this model is that our younger age classes, just simply because of cottonwood biology and what tree cores look like, we had to dump everything that's in the 0 to 12 year age class or 0 to 12 years, 0 to 2 centimeters into a single box. And you'll see that on the age distribution. And the same with our legacy trees. You can't sample a cottonwood that's over 50 centimeters DBH because the interior wood is rotten. So all of our trees over 82 years old are all lumped into another class. Okay, so here's what our size class, our DBH distribution looks like. So here are seedlings that are 0 to 2 centimeters. The one thing I want you to see here in this very first bar is that these are our youngest trees, 0 to 12 years old. This bar should be through the roof. In most organisms, your youngest size classes are 10 times the size of your next age class. So we do know that there's episodic recruitment, and clearly there has not been an episodic recruitment event that's substantial in the last 12 years, at least not that we were able to document in our sampling. And then the other thing that I wanted to point out is that all of these size classes, again, are aggregated into a single age. So here you're looking at the age distribution. So these are our seedlings that are 0 to 12 years. These two bars look the same. And then all of our 82 plus year old trees are out over here. So again, take home is that right now we should be seeing a lot of seedlings that then may be taken out over time with scour, but we just haven't had a large recruitment event in quite some time. Okay, so we know that it's episodic, like I said. This is another way of looking at the same thing. Our seedlings are fewer than our pole-sized trees. Okay, so then we also wanted to look at, so what is happening in terms of clonal, I just said seedlings, right? But we don't know if those are those genetic seedlings or clonal seedlings. So we tried to figure that out based on where they are appearing, where they appeared on our transects. So on both of these graphs, you're looking at each individual trees, are the dots. And on the right graph, this is the y-axis is where that individual tree occurred relative to water elevation at the time that LIDAR was flown. Oh, I'm sorry. No, this is relative water elevation of our survey. We did topographic survey as part of our sampling. So, and on the x-axis, this is the distance from the channel. So this is kind of this three-dimensional space here. So trees that are clustered closer to the water and closer to the water on the transect and closer to the water in terms of vertical space, we assumed were more likely to be genetic seedlings. And those that are further away would be more likely to be those seedlings that were reproduced vegetatively. So these are our mature trees over in this graph here. So these are poles and legacy trees, the larger trees. So if we had seedlings happening out here in space on this graph, we could assume that those are probably clonal in nature. So in Reach 6, mostly genetic seedlings. That's our most dynamic lower reach of the river. Here's our most confined reach. scatter of seedlings really matches the scatter of our larger trees. So we're assuming that reach 2 is primarily clonal in nature. And then here's a reach 4 had both seedlings that were occurring really close to the river channel, but also kind of mimicking the stand position in space as well. So by doing that, we were able to see that we had both sexual and clonal reproduction happening in 4 of our reaches and very little sexual reproduction happening in a couple of our reaches. So we also wanted to know what's the condition of the forest over those mature trees, what's happening. So we also looked at potential canopy. When trees are water stressed, there is canopy dieback. That's a documented phenomenon, and it's a way that foresters are able to evaluate tree health and tree stress. So we found that almost 75% of our trees are in good condition, but 10% are highly stressed, meaning that they've got only 35 to 55% of their canopy surviving. Now, remember, we're in the developing floodplain and the established floodplain. This is not the disconnected floodplain, right? This is not floodplain that's behind a levee. This is active floodplain. So that means that our something is happening with our trees. So why would cottonwood trees be stressed? First of all, cottonwood are, they're riparian, but they also can only tolerate conditions where the surface of the soil surface is no more than 2 meters above water. So they need to be able to reach groundwater. And they can become extremely stressed by changes in groundwater. They're actually fairly, at the time of establishment, their tolerance for changes in groundwater is pretty plastic. But if a tree gets established under high groundwater and that groundwater drops out 30 years later, that could cause a lot of stress, and vice versa. Maybe it establishes under low groundwater and then the groundwater comes up for some reason. Let's see, I think that's all I wanted to say there. So just summarizing the status of what we know. Our forests are extremely limited by our human development. We know that young classes are underrepresented, although less underrepresented than Bratney and his colleagues found in the early 2000s. There is so we know that new stand creation is extremely limited, probably mostly because of the lack of floodplain surfaces, but also because of the flow regime in the Kittitas Reach. One thing that is also a wonderful takeaway is that the clonal reproduction is more reasonable than I expected to find. And it's probably supported by our upside down hydrograph, so that during the growing season we have higher water tables that is supporting those mature trees, even though we have some reaches have a lot of stressed trees. So what do we, this is not all gloom and doom. As restoration ecologists, we always are thinking about, so what can we do about these problems? So in terms of each of these limiting factors, we were challenged by the available recruitment sites. And one of the main things that we can do and that we're doing in terms of identifying opportunities in this reach is to look at where can we expand the active floodplain by setting back structures and allowing that flood regime that's really, really critical to riparian recruitment to occur. We're also looking at how we can tinker around the edges of the flow regime. And the Yakima Nation has been kind of helping to lead this effort in how can we support flood flows on high water years where we've got a lot of water in the reservoirs to both establish recruitment sites, but specifically in the Kittitas Reach, how can we push spring flows at seed release up just a tiny bit so that those seedlings are recruiting higher in elevation than those subsequent summer irrigation flows. And then finally, what we usually talk about is where we've had cleared vegetation, how can we target reforestation in those cleared areas? So I wanted to wrap up with opportunities for regeneration. One of the things that we're doing as part of this study is to look at this 30-mile reach and identify restoration sites that have the highest value for fish and fish habitat and potential, essentially where from Mid-Columbia Fisheries perspective, where we have the highest value. So this graph or this image is showing you in the, gosh, I think that's looking yellow in this map, but it was orange. So in the red and yellowy orange areas are the highest priority areas in terms of the value that we would get for the restoration for fish. And then we're also looking at feasibility. So we know that landowner interest or the number of levees that we have or the infrastructure in an area, home sites are really going to affect feasibility. So in this map, you're looking at those same sites that we're looking at for potential restoration, and red and the yellowy orange are the highest feasible sites. So that's kind of where we're at right now, is identifying those restoration opportunities. So I wanted to close by a quick overview of some of our regeneration methods, to conventional planting, and then all the way to kind of more systemic, larger scale, levee setback or managing flows differently that are going to allow more stand creation. So this is the non-shovel methods down here. So more passive to more active, higher input. So we're probably all in this room familiar with conventional planting, where soil moisture is pretty close to the surface, using small plant material. You can do this semi-mechanized or just by hand, and then these kind of sites always require weeding and sometimes irrigation, depending on how close the water is to the surface. So other things that we can think about are using not just these standard kind of rooted material size. This is a 10 cubic inch pot right here, but you could use 40 cubic inch or the tree pot size where you've got longer. This is almost a 14-inch root mass here. But the important thing is to think about what those tops look like. So that's about a 3-foot stem to taller plants that have 5 to 10 foot tall stems. And this is used in some of our deep planting techniques where you can move away. Essentially, it's a way that we can efficiently put plants in the landscape without needing to irrigate later. So this is some work that WildLands assisted us with at a Cle Elum site. And here's soil moisture is quite a bit deeper. Those tall plants are then jammed in the ground using a hydraulic ram or stinger. I think Merritt Mitchell-Wadji from Mid-Columbia just made sure that our recent YouTube video that shows the stinger planting in action is on our YouTube channel. So if you guys want to check that out, it's pretty cool. So this is the same thing. WildLands also helping us with a planting at Spring Creek. So this is the 6-foot shank that can be jammed in the ground, and then a plant is installed here. So you're actually putting those roots into moist soil and not needing to irrigate. So it's a very effective way of putting them in and reducing your maintenance costs. Where we've trenched, this is using a 1-foot wide bucket and creating 4-foot deep trenches. Here's one of my colleagues showing how he put clusters of these riparian plants in the bottom of that trench. So lots of different ways that you can do that. But this deep planting method is only good for species that are adventitious rooters. So they can differentiate at buds along the stem. Buds along the stem can be differentiated into roots if they're buried, versus leaves or shoots if they're exposed to light and air. So not all species do this. It's really the kind of what I think of the true riparian hydric species, the willows. There's alder, red osier dogwood, and then of course our black cottonwood and aspen also can resprout that way. One last method that I want to close with is the idea of allowing recruitment to happen on our restoration sites in a manner that really requires no shoveling or heavy equipment to install plant material. One of the things that we could incorporate into constructed restoration sites, which we came across in Mid-Columbia Fisheries, used this technique accidentally a few years ago at the Russo Creek floodplain, where in the construction of a new side channel, the floodplain was also recontoured, and that floodplain wetted up right at the time of seed release of both black cottonwood and our willow species. And we now have about 5 acres completely unplanted of willow, 2 species of willow and black cottonwood that were not installed at all. So no shovels, no stakes, no bare roots, just seed landing on moist soil. So we talked about this on the site tour yesterday. Mid-Columbia Fisheries is partnering with Kittitas County to attempt a method that Chris Hogue, probably a mentor for many of us in the room, has been talking with me about, to create these bare, moist seed beds where we basically work up ground like you would for an agricultural field, and then have irrigation to wet that field up at the time of seed release, and then keep it wet for the first 2 years after seed release. So one of the key things is keeping it clean of weeds prior to that seed release period. So anyway, we're in the process of starting to do the chem fallow on that project. So we will keep you posted on how that works. I just wanted to thank the many, many people that were involved in this project. I know that it's time for me to close, so I won't go over it, but this was many minds and bodies and funding sources and a lot of support from partners. So it would not have happened without all of these many people. And if there's not time for questions now, please find me at the break. I'd love to talk more about this. Oh, we have a few minutes for questions. So thank you for your attention. I really appreciate it.
All right. Well, I just wanted to say, thank you for letting me present on the work that we've done in Douglas County on some of our beaver dam analogs and then some of our other projects. I really appreciate the opportunity to be able to talk about it. This was the first beaver dam analog project I worked on, and so it's really near and dear to my heart. And so I really love to share the knowledge about it and why we did this work here. So I want to start out and just thank our partners and funders, not only on this project, but on several of our other projects. So throughout the planning and implementation, the U.S. Fish and Wildlife Service and NRCS were integral, and we really couldn't have done it without them. During the implementation, we had awesome support from the Fish and Wildlife Service, the NRCS, Pheasants Forever, and Cascadia Conservation District. We also have really strong partnerships with some of our other local organizations. In 2019, Trout Unlimited, Cascade Fisheries, and Cascadia Conservation District formalized their partnership in something that we call the Coordinated Resource Management, or CRM group. And with this group, we're really able to amplify the work we do and really support each other where we can. And it's really been a great partnership. And we partner really strongly with the U.S. Forest Service as well. And I also wanted to say that Microsoft was the funder for the Rock Island Creek project. So just a little bit of background about Rock Island Creek. Rock Island Creek is this really beautiful stream that meanders its way through the shrub steppe of Douglas County. You know, we went there with the goal of restoring the historic wetland function that was present there. The landowners shared stories about how when they were younger, they'd water their horses in the beaver ponds or catch fish in the beaver ponds there, and they're no longer present on the creek. So we went there with that goal of bringing these processes back. Our goals there were to use beaver dam analogs in order to expand floodplain and wet meadow habitat. And we would do this, by aggrading sediment, creating pools and ponds, inducing channel meandering. And by doing that, we're going to push water up onto the floodplain and help to expand this wetland habitat. Not all restoration sites are the same, though. Many of our restoration projects occurred in areas that look like these places. The really heavily forested streams of the upper Wenatchee, or in the road-bound narrow canyons of the Entiat. Even though these areas are different, we had similar goals of putting these structures in. We use the same structures there. And that's because all these streams have something in common. They all once had beavers and now no longer do, and with them, they lost those functions. In these other creeks, we had a real focus on our ESA-listed fish species, so spring chinook, steelhead, and bull trout. But in a place like Rock Island Creek, our real focus was on the greater sage grouse that were present nearby, and then also on red band rainbow trout. And in these other creeks, based on what we had available, we used different structure types. And I'll get into that a little bit later, why we would use different structure types in different streams. So I just wanted to take a step back and talk about the importance of wetland habitat in shrub steppe ecosystems. So wetland habitat, or mesic habitat, only makes up about 2% of shrub steppe ecosystems, but so much wildlife relies on it. You can see why they call them emerald islands. That green just pops out of the drab shrub steppe, and a lot of creatures rely on it. If you attended the Restoring Riverscapes workshop last week, you'd hear the phrase, water is life, and that is certainly true in a place like Rock Island Creek. If you can also recall from that same workshop, Joe Wheaton succinctly said that, now I can't even remember what he said, but it was inefficient conveyance is healthy. And so through the loss of beavers in these streams, we lost the structures that were slowing the water down, and so that conveyance became very efficient. The water wouldn't stick around in the creek and would just go straight down, and we wouldn't be able to store it in these landscapes to expand this wetland habitat. So by building these beaver dam analogs, we're hoping to give the stream the tools it needs to treat its ailments, to add that inefficient conveyance back. Now, these are our two focal species we really, we're hoping to help by putting these BDAs in Rock Island Creek. Greater sage grouse are usually synonymous with their namesake, sagebrush. And mature sagebrush is so vital to sage grouse, but so is this wetland habitat. Wetland habitat produces nutritious forbs and plenty of invertebrates that is critical during the brood rearing stage of greater sage grouse. A higher proportion of leks are located closer to these wetland habitats. And so by building, by expanding this wetland habitat through building BDAs, we're providing more habitat, but we're also making these habitats more resilient so that sage grouse can rely on them more. And then these native trout also rely heavily on intact riparian zones. And so through building these structures, we were hoping to create a system that was more amenable to them living there. We also have plenty of other wildlife that lived on this creek. There was cougar sign, bear sign, horned lizards, which was a real treat for me. Tons of invertebrates in the creek. And so the life was there, and by building these structures, it just highlighted the importance of what we could do on site. So now, maybe stepping back a little bit on BDAs, some of you might not be familiar. So what is a BDA? BDAs are our approximation of a beaver dam. We try our best to put on our beaver hats, get in the creek, We pound posts in the stream and then weave them with native weave material in order to try to approximate the function of a beaver dam. We're obviously not as good as beavers, but we can do our best to try to mimic some of these functions in order to produce some of the same benefits. We use different types of BDAs too, depending on the situation. We'll use channel spanning BDAs, which are exactly what you would think. They're perpendicular to the flow of water, and once woven, they create a nice pool behind them. And we use these to help aggregate sediment. We also use the ponds as a way to push that water up and onto the floodplain, which will in turn help raise the water table. We also use deflector BDAs, and these are placed quartering across the stream, and they don't span the whole channel. And this helps direct the flow of water into the opposing bank. This will help erode that opposing bank, which will donate sediment to the stream for downstream aggradation, but it'll also help encourage that meandering, that sinuosity, allowing the creek to play through its valley bottom. So here's a little bit about planning BDA projects. Some BDA projects are really easy to plan. We had one project that went from implementation or inception to implementation in less than a year. Rock Island Creek took a little bit longer. It was started planning before I was even on the project, and we implemented in 2021. So there were several years of planning on this project through landowner connections, permitting, laying out structures. And when you're going to plan these structures, you really have to read the creek. You have to be like a beaver. You have to say, all right, even like, where am I going to be able to put this structure that's going to have the intended benefit? You're looking for pinch points just as a beaver would, so that if you put a structure there, behind it, it's going to create a pond that's going to push water up and onto the floodplain. And it's more of an art form than a science. There's no rule of, a BDA has to be 10 foot from another BDA. You're really just trying to do it site per site, creek per creek, figuring out where these structures are going to have their best benefit or where you think you're going to have your best benefit. And that's why it's important to adaptively manage these sites so that you can monitor how the effects are being realized on the landscape over time, and how, as you see this, you can add more structures or modify structures as you see fit to help meet your restoration goals. So permitting and cultural resources are a really important part of these BDA projects. And this is something that I'd really stress to get done in advance for any of these projects. We had that Alder Creek project that I mentioned that had, from inception to implementation in less than a year. We were in a real time crunch to get our permitting and cultural done. And while we were able to get it done and get the project done on time, it was really stressful and not worth it, to be under that time crunch. So if you can have this stuff planned a long time in advance, that's really helpful. And so the types of permits that you'd need are an HPA and a JARPA permit, which you would submit for with your local WDFW's wildlife biologist. And you'd need things like a pretty detailed site plan, but the great things about BDA projects is you could put a range of structures. So for example, we said we were going to put 25 to 40 BDAs in this reach. And that gave us the play to say, all right, we want to put a structure here, but once on site, we can determine if we want to drop it, move it, modify it a little bit to better fit this, what we're seeing on site at the time of implementation. So now into the actual Rock Island Creek project, a little bit more about the preparation we had to do. This project site was far from roads, which is great, right? The stream can do what it wants to do. We don't have to worry about any infrastructure. The nearest road was over a mile away. So by building these restoration structures in there, we're really giving the stream the tools it needs to heal itself. It can meander as much as it wants through its valley bottom, and we can do as much work as we want there in order to repair that riparian system. But this also poses some challenges. There's a lot of equipment that's involved with building BDA projects. You need to bring posts down to the stream. You need to have equipment to pound the posts. You need to get people down there, supplies, all of that. And so by being over a mile from any roads, it was kind of hard to figure out what we were going to do. And until we actually implemented the project, we weren't sure it was going to work out. Luckily, there was an old 2-track. And when I say old, I mean really old. That's the 2-track that we used to get down to the creek. And we were able to use a U.S. Fish and Wildlife Service UTV to deliver our posts, 50 posts at a time, down to the creek bottom. multiple trips every day. And we were able to do it. It took some doing. Once we got all the equipment down there, we tossed a tarp over it, and we were able to keep all the equipment down there throughout the implementation. So now, the most exciting part of building BDAs, or one of the most exciting part of building BDAs, is the post pounding. This is the hard work part of it. You're lifting a 70-pound power head over your head in order to pound these posts through the stream bed. We installed about 25 BDAs in about a quarter mile of Rock Island Creek in September and October of 2021. We had a lot of partners, like I mentioned earlier, Cascadia Conservation District, the Fish and Wildlife Service, NRCS, and Pheasants Forever were so important because in one day we were over to install over a dozen BDAs. And so having those partnerships is key to ensuring that you're getting these projects done on time. And, we really do like to stress that support from our partners, because you can see that wheelbarrow there that we're using to move around our equipment. So when we were down at the creek, we weren't having to lug these heavy pieces of equipment around all the time. We were able to use some of that. And now onto the weaving. So this is another moment that you can put on your beaver thinking cap, right? When humans try to build stuff, we usually try to build things really neat, right? We want it to look nice. We want it to have really tight weave like a basket. And while that can be pretty, we don't want to do that. You want your BDAs to be messy. You want to throw out that neatness. Because when you look at a beaver dam, when you look at a cross-section of a beaver dam, right, that looks pretty messy. And a beaver doesn't care what a dam looks like. They just care how well it holds water. So they're not concerned at how pretty it is, even though I think beaver dams can be quite beautiful. But if you took a cross-section of that dam, you wouldn't see a two-dimensional structure. You would see almost a trapezoid, a ramp up from the pool over the dam and down on the downstream side. And that's really important to a dam's function, to a beaver dam's function. And we tried to do that in our BDAs too. And you can see this trapezoidal three-dimensional shape here. And that's important because during high flow conditions, the force of water going over the BDA has the chance to undermine, go over, toe scour, and cut back underneath, removing those center posts. So by building this really messy, big structure, you're adding a lot of surface area, which is going to help disperse that flow, add heterogeneity to the flow, and disperse the energy as it's going over, so that you don't have to be concerned with toe scour as much. It's still a concern, but it definitely helps to solve that issue. And look at that, a happy beaver standing next to his work. So some implementation challenges. I mentioned them a little bit throughout, but this stuff is hard work. It's, by the end of a day building BDAs, you're pretty beat. And so by having those, good groups of people, you're able to alleviate some of that stress. Fire is also a concern. We're working in these dry areas. We pushed back this project later into the fall to help deal with some of our fire concerns, but it was still something that we were worried about. In Rock Island Creek, we were really lucky with the substrate type, where it was pretty soft, and so we were able to pound in a ton of BDAs in a day. But in other creeks, such as our Alder Creek project or another project we had on Potato Creek up the Entiat, the substrate was really hard to pound in. And so we had to drop some structures at some points, or we would just have to spend a lot of extra time slowing down the project in order to get these structures in. It's really easy to go overboard with these structures. Once you're in the mode of building BDAs, you want to keep building. And, it's easy to get into that mindset, and then that's when you're going to get hurt. I mentioned the access issue earlier. Some of the creeks that you want to treat aren't going to be in a convenient location. And so trying to come up with creative solutions to those problems is really important. So some other projects I wanted to highlight that I mentioned earlier that use different structure types are our Alder Creek project, which is a tributary of the Chihuahua River, and then 2 phases of our Potato Creek project, which is a tributary of the Entiat River. And so in these locations, we use both channel spanning BDAs and deflector BDAs, but we also added additional structures. We used something called PALs, which are post-assisted log structures. And PALs are really great for adding wood to streams that are lacking wood placement, and that helps add heterogeneity to the flow and adds a lot of habitat for fish. We also added unanchored wood where we could opportunistically, but we didn't do that in Rock Island Creek. And so the main reason for that is because a lot of the wood that we used in both Alder Creek and Potato Creek were already on site. We didn't have to import a ton of wood in order to add these structures. In Rock Island Creek, we would have had to bring logs down in a place that was already a challenge with the access issue. So we figured we're going to do what we can on site in Rock Island Creek. And then in these other locations, we took advantage of the existing material. For example, you can see this giant log that we're using PVs to wedge down into the stream that was already perched over Alder Creek. We're just nudging along that natural process. That wood end up in the creek anyways. But by getting in there with some tools and spending, an hour or two, we were able to nudge that along and create some really awesome habitat without much effort. These other projects had different challenges too. Access was not an issue like it was in Rock Island Creek. Anyone who's been at Potato Creek or has been near Alder Creek knows that there are tons of roads in that area and that you can drive up to all the sites that you need to, drop your post, drop your equipment, and it's not that huge of a challenge. But that's where the substrate was the issue. In Alder Creek, we had really cobbly, rocky substrate. So pounding was really tough. And, we ran into some challenges with our BDA post quality as well. And so that made pounding even more difficult. And so in Alder Creek, we actually had to drop some structures that we were planning on just because of our post quality and the substrate type. In Potato Creek, that project was completed in 2 phases. The first phase of Potato Creek was led by Trout Unlimited, and that was completed in 2020. And during that phase, they were using a pneumatic post pounder. Now, a pneumatic post pounder is really nice because it's lighter, but it doesn't have quite the impact strength of the new hydraulic post pounders that we're using in these pictures. Lower down on Potato Creek during implementation, the stream ran dry. So the substrate was really hard and compacted. During that first phase of implementation, they just couldn't get the structures in that lower section. And so they decided, we have to forego these structures, and they left it. Luckily, in 2022, the CRM group led by Cascadia Conservation District came in using the hydraulic post pounder. We were able to revisit that site and install these BDAs in the dry stream bed where the pneumatic post pounder wasn't usable in the past. And so that's the real benefit of doing these projects, over years, is that you're learning from each of them. And so I just wanted to share some post-implementation pictures from this Rock Island Creek project. If you look over here, this BDA is that one that you saw us pounding in that implementation post-pounding slide. So you can just see how much wider the creek is, just following some light work through weaving and pounding post into the stream. And while it's not as big as a beaver dam would be, it's certainly a start. And it's definitely helping to push more water up on the floodplain. And during higher flow conditions, you can imagine the water starting to flank this and meander throughout this floodplain more, wetting more of that wetland surface. Here's another view of a BDA that's woven, just creating that really awesome, deeper habitat that's going to be so critical for the trout that live there. And it's really wetting that floodplain to produce awesome vegetation for the sage grouse. Here's another view of these really terrific BDAs and how we're flooding some of this existing structure so that it's more available to the organisms in the stream. And so, just like beaver dams, we need to maintain our BDAs. We don't quite have the luxury like beavers do to work on them 24/7, so we'll never be as good at that as them, but we try our best. And this is another moment you put on your beaver hat. You're getting in the stream, you're feeling around, trying to feel where the water's flowing through and using what you have on site to plug those holes and restore that function. And within just a few minutes, maintenance can really have a lot of impact. And here's the after picture. You can see how, just by moving, I used a lot of this watercress that was present balled it up, found the holes, plugged it in 10, 15 minutes, had increased the water level by several inches. And so being able to maintain these structures is so critical to their function. By maintaining them, you're ensuring that they're storing that water, that they're ponding that water and creating that habitat. We also take measurements of all of our BDAs. Currently, during low flow conditions, so between July and September, we take wetted width, wetted depth, sediment depth, and pool length of all of our projects. During August of 2021, before implementation on Rock Island Creek, we took pre-measurements, pre-implementation measurements at all of our marked out BDA sites in order to compare. In August of 2022, when we went to do maintenance, we also took those post-implementation measurements, and we saw an approximate 50% increase in wetted width and about a 45% increase in wetted depth between pre-implementation and post-implementation. So we saw that as really incredible for expanding that habitat available in Rock Island Creek. We're also working to continue standardizing our monitoring protocols. We really want to ensure that as new people get hired onto the project, they're able to take what we've done in the past and compare data from several years down the line to data that was initially collected before implementation. And just wanted to talk about some lessons learned on these projects. Partnerships are key. We wouldn't be able to do it without any of our partners, right? By having people that you can switch out post-pounding, you can expand the amount of time that you're working on a project. Not everyone is getting gassed by lifting that heavy power head every time. Something else that is really important to note is that, even though you have all these people, you got to know when to call it quits for the day. When you get to that point and you're like, we can get that one last BDA in and everyone's tired, it's worth it to just say, you know what, we'll come back tomorrow. The posts aren't going anywhere. The stream's not going anywhere. Being able to adaptively manage these and install BDAs in phases really affords you that opportunity to learn from these past struggles. I think that Potato Creek example is the perfect example of that. The first phase went in, they installed a ton of BDAs, weren't able to install some. There was a couple-year period where we were learning from that, watching how these BDAs responded, and then coming in, we were able to add more BDAs and some other structures there to try to fill in the gaps where in the past we may have had some limitations and couldn't do that work. And then, this might seem kind of, it might make a lot of sense, but don't use hawthorn for weaving. Someone cut a bunch of it and it really sucks. It does work, but it's not worth it. Going back to the weaving, using plants like conifer and sagebrush is really great. All of that surface area in their branches and needles adds a ton of surface area to that weaving, allowing you to really make those BDAs messy and get some, tighter weaves on your BDA. And then just some next steps. We have additional phases planned for Rock Island Creek. This fall, we're going to install an additional, hopefully 70 to 80 BDAs, learning from the 25 that we put in 2021. We're also updating our monitoring techniques. I mentioned earlier the standardization, but we're also looking into using drones to measure NDVI. Some others, especially that Silverman et al. 2019 paper, really demonstrated how NDVI can be really great at showing the impacts of these restoration projects pre and post implementation. And then also beaver relocation. Those landowners really want beavers back on their property. And so it's a hope of ours and a goal of ours to get beavers back there. And we hope that someday those landowners are going to be able to water their stock and catch those fish in those beaver ponds again. I wanted to take one more second to thank all of our funders and partners. Really wouldn't have been possible without them. And I can open it up to questions if anyone has any.
Those who know me know that. Thank you all for being here, and it's an honor to be here. I'm Scott Nicolai, and I've been a habitat biologist for the last 35 years or so. And I want to make sure that I emphasize that one of the things that I love about my work now is getting to interact with young people like Samantha Bango, who is my co-collaborator in this presentation. It's a scary world, right? Not just environmentally, but politically, socially. It's just a scary place. And if you care a lot about the people around you and the natural landscape, it's pretty easy to get demoralized. So the reason I hope to stay involved and still be setting chokers and bantering with folks when I'm 80 is because this gives me hope, right? This is like what I and probably most or all of you need to be doing, is doing some of the work that matters. So my hat's off to Sam. She's 30 years old and just a rock star. She just puts her heart and soul into this. And unfortunately, she's leading a restoration team down in Utah right now and has plenty of things to do. I want to start with asking if you found a bottle on the beach and rubbed it and the genie popped out and said you get 3 wishes, what would they be? Yes, Katrina. Improved flow. Okay. All right. That's a good one. That's a good one. There's a lot of good ones, right? And scaling it back a little bit, a lot of us, I think, who are in this field would want, for better or worse, to see what this landscape looked like 200 years ago. I think that, at least for me, it would really probably be sad, right? But it would also be very enlightening. It would probably shift my paradigm. I know 25 years ago when I was putting rocks in rivers and calling it fish habitat restoration, that it would have shifted my paradigm, right? The world's changed a lot. And I get the pleasure now of working with Anabranch, and those are the folks who wrote Process-Based Restoration Light Manual. And this is one of Dr. Joe Wheaton's slides about the valley bottom, right, and what we've lost because of all kinds of things. This picture, Dr. Ellen Wool wrote a great paper that you should look at if you care about streams and floodplains and restoration. The title is Legacy of Wood Removal in the U.S., something like that. And this slide is of the Red River down in Texas and Louisiana. And we worked systematically with public funding through the Corps of Engineers, who had a snagging funding program, to remove this log jam from the Red River. It was 165 miles long. They removed the whole thing, a flood happened, the log jam came back in, and they removed that one too. So just think for a minute of what that used to look like, right? I've got a couple of glamour shots of big beaver dams. These next 3 slides were taken on Spawn Creek, which is a trip to the Logan River up in Utah. This one's great. It's impressive. It's about 12 feet tall, almost 100 yards in length from one side to the other. If you go there and camp in the evenings in the summer, you'll see perhaps 8 beavers milling around that pond. It's impressive. This one impressed me even more, not so much because of its size, but because of how incised, steep, no floodplain, nice and tight the stream channel is. There's no floodplain. And it's got a really high gradient. The gradient on this stream is probably 8%. And look at that beaver dam. And upstream, check out the lodge. Look at how big it is. Paul is one of the restoration technicians, and he's over 6 feet tall. Raise your hand if you've seen this advertisement from 1935. I only see a couple of hands. Really? You need to look at this. It's on the internet. DuPont Dynamite, Streamlined Streams. This is from 1935 in a forestry publication. The opening line is, crooked streams are a menace to life and crops in the areas bordering their banks. And they talk about, extol the virtues of using dynamite to straighten streams so that they're not ruining your crops and causing flooding and all those things. The best line is the last one. DuPont has an explosive for every purpose. Just love that. Whoops. Shifting legacy. This, a former colleague of mine put these series of slides together. This is over 10 years. The first one is in 2003. This is right here in the Teanaway subwatershed of the Yakima on Indian Creek. So this is 2003. I'll give it away right now. This little floodplain was just pounded by livestock. That's 2008, 5 years later. And that's 2013. So that's channel incision before your very eyes. So a lot of the streams that we see look like this now. And the young me would have gone out and said, hey, this is great. Stream's got nice, healthy riparian vegetation, but this hastily drawn yellow line shows that the stream's really incised, right? It's not well connected to its floodplain. All right, so now I'm going to talk about lessons learned on 3 of the case studies that I've collaborated with Anabranch on. This first one is in Asotin Creek watershed way down in southeast Washington. So I'm going to have slides from each of those tributaries. Before I do that, again, I want to pay tribute to the folks at Anabranch. This is supposed to be a really funny slide because this is after a day of working in a place that had burned. And we were all really dirty. So this is Dr. Steve Bennett and the restoration crew. That's Samantha on the bottom and her colleague Alex. But these folks have done trainings and restoration in 7 states around the western U.S. So what are the lessons learned from Asotin? Well, in 2012, Asotin is an intensively monitored watershed. So the way this study design was set up, there's a control and a treatment reach. And in the treatment reaches, they were going to use low-tech process-based restoration. Well, in 2012, when they started, this is what the structures looked like. Very small, very simple, a few piles and some large trees. 10 years later, they were using a lot more material, a lot more piles, and a lot of slash, a lot of fine material. And looking at this closer, they were keying in on places where they could, where there's a side channel that they could reconnect. So all of us installed this, and then we got this beautiful side channel that's reconnected somewhat. They learned the hard way that you need a lot of piles, especially if the substrate doesn't lend itself well to putting them in deep. We also started just dropping wood, and that's something I've been doing in other watersheds for quite a while now, where you're just putting wood into the stream and letting the stream sort it out. So this was the large stuff was dropped in 2021, and then it went through a pretty decent high flow and racked in all this smaller material. In Charlie Creek, this is a place that if you're not a believer in BDAs, I encourage you to go out and look at this. This definitely helped me. So on Charlie Creek, flows from bottom to top. We built a BDA here and watered a side channel The thing that I really learned on this one was that Dr. Bennett, Steve's really emphasized putting apron material on the downstream edge of the BDA so that as the flows come up, you're experiencing a high flow, perhaps a bank full channel maintaining event. It's not just dropping off and creating a scour pool on the bottom side of that BDA. It's actually has a ramp to run down. And I hope this is this a lousy slide? Raise your hand if this is a lousy. Come on, be courageous. I'm sorry. Sorry about the color. Anyway, the main channel's on the top, and that side channel that single BDA rewatered is on the bottom. And the thing I like about this is this feels to me like it's a pretty stable structure, because as the flows come up and the stream is really doing its work, it's got places to go. If you want to reduce erosive power, the way to do it is to spread the water out, slow it down. And that's what this structure is doing. So Soton IMW, again, it's an intensively monitored watershed, so it's pretty fish-centric. The first bullet is a real shocker. Wood additions actually increased overall. Wow. There's more geomorphic complexity in the treatment reaches. Juvenile steelhead increased, which is cool because they're ESA listed there. Just a shout out, I guess, to my former employer, Yakima Nation. We all know that fishing for anadromous fish is culturally, like, that's one of the biggest deals to traditional tribal people. If they lose their fish, they lose their culture and perhaps a huge part of their religion. Because we don't have many steelhead, they're not able to fish for populations, stocks that are still abundant. Fall Chinook, in some cases, they're unable to have a commercial fishery on because of concerns with bycatch. So let's get the steelhead return for all sorts of reasons, including tribal harvest. Another bullet was more material is better, and I'll keep coming back to that. Next one, Willow Springs. This is the second of three that I'm going to talk about, and then I'm going to close with a couple of other comments. This is Willow Springs is a site down in Waichus Creek, about central eastern Oregon, just north of Sisters, north of Bend. This is a less than enthusiastic partner, shown for scale. My wife of 35 years, shout out to Judy. Standing for scale in front of the material that was staged for 2 years prior to placement in the stream. This is most of the stockpile. It was about 120 yards long, stacked crosswise. There was a lot of material there. And it was a bummer because it had been stashed there for so long that its quality had begun to degrade. I'll come back to that. So we used the tractor as the drone image to pick the material out of flatbed trailers. The land trust that owned and managed the property didn't want us dragging material up the restoration reach, which was about 0.8 of a mile in length. So we picked it off the pile, put it on a 20-foot flatbed, carried it up, took it out. It was kind of labor intensive. I'm a big advocate for harvesting your material on site if you can. Harvest it when you're actually doing the restoration if you can. And yeah, just full length, take the tree down, put it in the stream. A lot of times permits won't let us do that. And Jen, don't let me get going on permits, right? So this is Celeste, this gives you hopefully idea of how compromised the material was, this is a pine rootwad tree, about a 10-inch diameter tree, and she's literally just dragging it up the channel. It was light, friable, limbs were breaking off, but we moved a lot of material. Once it was in the channel, it was all moved by hand. It was just shocking to me to see how much material 8 restoration crew members moved by hand. Installing the material, lots and lots of pilings. You can see Alex there holding right up there, holding the piles, and they put in a lot of piles. Same way as Michael was putting them in. There you are, Michael. Yeah, same way. Wear a hard hat when you're driving piles, right? This drone just shows stream flows from bottom to top, and they put it in exactly the opposite way that I would have put it in 25 years ago, right? Paradigms should shift. No matter how you're doing your project, there's a better way to do it. The river's smarter than we are. I hope that you approach your careers with some humility. You might be wrong. I was way wrong, because 25 years ago I would have said, oh my God, a calving bank, fine sediment, that's bad. We got to put a lot of rock and wood on that outside meander to stem the erosion. Now we're doing the opposite. We're doing process-based restoration, where we're encouraging sinuosity, lengthening of the channel, hopefully aggradation, building up of the stream bed and better connection with these streams that have suffered the wrath of misinformed people using dynamite, cows, tracked excavators to straighten and simplify channels. So now we're trying to actually encourage erosion. Erosion's good within reason. Alcohol's good within reason. Wish my dad would have learned that lesson. The coolest thing about this project was they straightened the stream. Guess what was next to the straightened reaches? A berm of material. How did it get there? Well, they dug out the channel and put it right there next to it. And we actually got to remove a bunch of that and just push it right into the stream, right? I think if somebody from the Seattle office of the Corps of Engineers would have been out there, they probably would have wanted to cite us. They said, remember that you can only remove or push less than 50 yards of material, otherwise you need a 404 permit. Jen, it's your fault. You got me going again. So anyway, we pushed the material in, thank goodness. Sam and her crew put a whole bunch of wood in the former channel. Here's that former revetment. A whole bunch of new alluvium, old alluvium that had been mismanaged, pushed it into the stream. Uh-oh. Oh, careful, you'll give me a heart attack. So this is a drone after a pretty decent flow last December, I think. So former channel, lots of wood, former revetment, increased sinuosity. Makes me smile. What? Why am I going backwards now? Okay, here we go. So lessons so far, the wood's coalesced into fewer structures, revetment material increased sinuosity. We put a bunch of BDAs on the floodplain. They haven't been exercised yet. The flows haven't come up enough. We haven't been able to push enough material back into the stream. We haven't rewritten the Clean Water Act so that restoration work can happen without onerous permits. And I already said it, but if you can harvest, transport, place your material when you're doing the restoration, you're going to save a ton of money and the quality of the material will be higher. green trees, when you cut them down initially, and Zach knows this, are green trees hard to grip with, Zach? They're heavy, right? Trees lose 30 or 40% of their weight when they go from green to ready to put into your wood stove. So harvest them and place them when they're green. Last one, Bailey Flat, way down in southern Oregon in the Klamath Basin. If I had that genie, I would say, Genie, give me about 100,000 restoration or practitioners like you all, and let's all go down to the Klamath Basin and work there for a year. And let's do it in a way, maybe one of my other wishes would be that we don't need any permits to do the restoration. That'd be cool. So this is post-project. This about 1.1 mile stream reach, privately owned, Trout Unlimited funded through Partners for Fish and Wildlife. Thank you, Katie. Katie way in the back from U.S. Fish and Wildlife. That's how this was funded. Pre-project on left, no woody material from sea to shining sea. We put a bunch of material in there. All of it was harvested on site. I was smiling the whole time. Left before, right after. This sub-drainage was at the edge of the bootleg fire. I was really worried I wasn't going to remember the name. The bootleg fire happened in 21, I believe it was, 400,000 acre burn in southern Oregon. Forest fires are becoming more common. They're burning more catastrophically, right? If we re-wet our floodplains, then those floodplains don't burn as much. They're actually using restored stream reaches as part of a fire break now when they're trying to manage fires. So where was I? Oh, so one of the goals with this was to trap sediment from that big fire. And it did. We did. We walked out there a week after we started the project, and we were already trapping gobs of sediment in the lee of those structures. Lessons learned, high flows redistributed and coalesced, same as last one. Bigger is better. Large trees tended to move shorter distance. We actually tipped over some junipers down in this country where they have lots of junipers, and they really want to get rid of some of them because they are not a fire-tolerant species. We've been suppressing the fires, so there's lots of junipers. The forest ecologists say that junipers are a net loss for groundwater. They suck up more groundwater than they retain because of the shade that they provide, which is the flip side of ponderosa pines. So they want to get rid of them, and they're a great restoration material. So we actually were able to tip over some junipers with the root wad and drag them in. And those were more stable because they were green and heavy and they had root wads attached. Okay, so a couple last comments. How am I doing on time? Oh, 3 minutes. Okay. Well, why does this matter? Well, this is a shot I took way back in 2011 when my cousin Adam, where are you, Adam? There's Adam Hess back there, who's my best friend's son from high school. My first cousin was my best friend. He's his son. So Adam was probably in high school then. Anyway, doesn't matter. This is a reconnected floodplain because we put wood in the channel, right? And if you're worried about climate change, holy cow, what a great thing to do. I've taken 24 tours out to projects and very diverse, politically diverse groups. And I say, how many people, raise your hand if you're in favor of streams with cold water in July, right? I see a hand. The rest of you are apparently not. Anyway, This is cool, right? There aren't very many people who are going to oppose re-wetting a publicly owned floodplain with floodwater. It attenuates flood peaks a little bit downstream. So there's that same reach, and it still gives me chills, 12 years later. It's just, and I don't even have to stand in the cold water to get chills. What about riparian response? Well, Becca Wassel and Brian Dieknicker took the lead on some restoration work, amazing restoration work in the Teanaway. And the river still hasn't done its part of the restoration out there, maybe a little bit. It's about time. Yeah. Do I get to start over? No. Because the Teanaway hasn't flexed its muscle yet and shown us who's boss and moved that wood around and deposited sediment, beautiful, fine textures, sediment, thousands of dump truck loads of sediment. I'm not excited about that project yet, or no, I'm not gratified. I'm still in the wait and see mode. It's not Christmas morning yet in the Teanaway. But it has been in other places we've worked. On this project, I just got damn lucky because we put the wood in and 8 months later we had the flood of record. So beautiful sediment, lots of seedlings. Didn't plant any of them, obviously, that's just natural. Here's what it looked like before the restoration, and here's what it looked like 3 years later. So reconnect streams to floodplains. Remember that you're making a suggestion to the river. BDAs, post-assisted wood structures, loose wood, which is written up in the Stream Habitat Restoration Guidelines as a method. And Brent Renfro, who's also here, really, my hat's off to him for encouraging me back in a long time ago to use this technique. It feels a little reckless at first. That reconnects streams to floodplains and kickstarts the recovery of our riparian zones. You all must see this short video, if you haven't already. Oregon Public Broadcasting put it out. It's on the web. And it's about Bridge Creek down in Oregon. And a guy named Chris Jordan from NOAA Fisheries. Raise your hand if you know Chris. No one knows Chris. Okay, he started putting BDAs in there back in the mid-2000s. A lot of those BDAs are now just covered in silt because the beavers came in and started partying there and making a beaver mecca out of it. And this talks about fish response, and it's just another one to make you smile. Okay, so I'm going to shake it up just a little bit. I've got one more slide that I want to show you before the close. Whoops, there it did it again, darn it. So this PG rated slide is of my granddaughter. And she was born back in October, and I'm going to try not to get choked up here. I get choked up from Christmas commercials. So I'm doing the work I do now for her generation, right? She inherits the world we leave for her. She stole my heart the day I met her. And I want to ask you, what does it mean to love something? So I think about that a lot now. I love the natural world. I have my whole life. And I love this little girl. And for me, the most basic thing is you want to protect that thing from harm. Right? There's all sorts of other things you could say, but protect from harm is at the core of love for me. And I think that probably all of you love other people, even perfect strangers. If you see a pedestrian walking down the road and a car is careening toward them and it's going to hit them for sure, you're probably going to try to help them avoid that. So my hat is off to you for what you do. You're helping to foster a more vibrant biosphere. And at my age, I get to say that, right? You do too. It's just maybe a little easier for me now. So thank you all for what you do. Feel free to give me a call anytime. I do a lot of volunteer work these days, much to the consternation of my partner of 35 years. She'd like to have me around more often. But we're all in this together. Oh, I didn't mention that. That's another one of my deals, right? Is we are all in this together. We are stronger as a community. Ideas crafted by one person aren't as good as ideas that are vetted with a larger group. I've been wrong many times, right? So work together. Partnerships. Who mentioned partnerships? Michael, you did. Partnerships rock. They're awesome. And be patient. Yesterday, Katie mentioned being patient on one of the field trip stops. If your project hasn't worked after the second year because the stream hasn't flexed its muscle, it doesn't mean it's not going to work, right? Be patient. Okay?
Not to put you all to sleep. So, insiders outside. Walla Penitentiary offsite crew and restoring riparian areas. Next slide. Okay, so what we're going to be doing today is here's just a brief overview. Is how to initiate a program of offsite corrections crews, how to work with the personnel, officers, overseeing the crews, advantages of working with these crews, and then also issues and challenges with working with these crews. Next slide. So it just gives you a bit of an orientation of where we are. This is the Walla Walla watershed, and it's in the very southeast corner of Washington State. And these are the major streams. Next slide. So Walla Walla, one of the interpretations of the Native American name is area of many small streams, which it is. These are all the streams that we do restoration on and water quality testing on to see what's happening after our restoration. So these are, we have 18 sites on these streams, and I mostly work with Whitman College students on those. Next slide. So here's how the program got started. Next slide. So on the left side is the Murfield, which is at the, it's a recreation field, baseball field for Walla Walla High School. And this is Yellowhawk Creek. This is what we look like on most of our streams. And then this is a crew that I started working with initially. Otherwise, I had been working a lot with volunteers, and other people are still doing that a lot. Conservation District, Tri-State Steelheaders. And these crews, I never knew who was coming, how many were going to be there, how old they were going to be, how young they were going to be, how pregnant they were going to be. And so, but still, they did a good job. They had a really nice guy working with them. But this program got defunded at the state level. And so suddenly I had grants with funding for crews, and I didn't have anyone to work with. So next slide, please. So this is Washington State Penitentiary. And it was founded in the early 1900s and is a maximum security prison. And they hold powwows for the Native American people who are incarcerated there, who also make regalia for their people on the outside. Next slide. And they also have a GED program, and I have a couple of friends that are teachers there. And I talked with one of my friends, and she knew the supervisor, and I told her my predicament, and she said, well, why don't you talk to the supervisor and see if there's any possibility of something happening. So I met with the supervisor. Next slide. You can keep going. One more. And he was actually looking for a kind of a program like this. So I initiated this first program. There are now 3 sets of crews of 10 people each. And the crew that I work with is specifically one that works on streams. Otherwise, I'd have a hodgepodge of different people every time I went out, which doesn't work, as you might know. So these are the fees that were set. Now, $250 a day plus L&I insurance, 10 guys for six hours. And when I first started, I had all the hand tools. So every morning I'd load them into my pickup, take them out to the site, crew would use them, load them back up, and take them home. And then after the first couple of years, the penitentiary started buying the tools themselves, which is really helpful. So they have a van, they have a trailer, and they have all the tools that we need. The people that we're working with are minimum security, generally in for drug or alcohol related. I never know what any individual person will be in for, but sometimes they volunteer, but usually I don't know. I've had several officers, but one I had until he retired for almost a decade. Really liked to work with the crews. He liked to build teamwork, and he really enjoyed the program. He retired. I have another officer now that I've had for almost 2 years who also has the same attitude toward wanting to do the work, liking to be outside, working with the crews. And everything works pretty well. The politics at the prison can be a problem. At one point, I had a person who was scheduling, and it was very difficult for her to understand how important it was for me to have the same people on the crew each day. And part of her reason for this was that if she scrambled the crews, there might be less likely of somebody bringing drugs into the prison. I've only had that happen twice in 15 years. But it's always something that we have to be looking out for. And it's just part of the program, because these fellows are mostly in for drug and alcohol abuse, and the prison is, anyway. But it actually hasn't caused that many problems. The last time it happened, it actually wasn't my crew. It was with some crews from another crew. Okay. Next one. So I'm just going to show you a variety of places where we've been working and some of the things that they have to do. When we started, we were working with a program that worked mostly in town, creating urban riparian buffers. That program got defunded in about 2015 because we can't get buffers 50 or 75 feet out of people's backyards. Worked a lot with schools and churches and city parks. So I think with Conservation District and Tri-State Steelheaders, we did between 50 and 80 projects in about 5 years. So this is at the Walla Walla High School. This is what they started with. This is about 1,000 feet long. Blackberry's 50 feet high and 30 feet wide. Next slide, please. This is what it looked like afterwards. This is just a line of black locust trees, non-native trees that were planted on all the creeks in the 1930s by the CCC. So it's just basically the only remnant vegetation or trees on any of the creeks. And otherwise they're overgrown with blackberries and non-native species or lawns down to the creek. Next one, please. This is in Yellow Hawk Creek, digging reed canary grass out of the creek. And so we worked with a school district and helped get funding. I think this is with a Hussman grant. And so we also worked when the school wasn't in progress. So we worked during the summer months. So that's one of the things you have to do is you always have to make sure that the neighbors of wherever you're going to be working are okay with the crews being in their proximity, and of course with the landowners. Next slide. So this is out on the West Little Walla Walla River. This is a, totally reed canary grass. Due to some upstream water management changes in 2001, they lost their stream flows in the summertime, and it filled in with reed canary grass. And so we've been working with that. The farmer, this farm was founded in the early 1860s, and so these are some of the oldest water rights in the basin. Next slide, please. This is the farmstead. Again, pulling out reed canary grass. And the fellow who owned the farm, Yancey Reeser, was in his 80s when we were doing this, and he's since died. But this filled in like in 5 years, and we had beaver come back and start chomping on it. But Yancey had lived on that farm his whole life, and when it was really a flowing stream, and he was thrilled to have the beaver come back, which are still there. This is again Yellow Hawk Creek. This is a recent project. This is another example of what we're facing. This is actually just one huge box elder tree that was hit by lightning or something and fell down and just sprouted all along. Next slide. And this is them working to get rid of the branches and things so that we can get in under and around these trees and do some planting. Next slide, please. So one of the pieces of equipment that they have is a chipper. And so when we have small brush and debris like this, we chip it all and leave it on site. So all the wood that we use stays on the site. Next slide, please. So these fellows, get interested in, and they come up with these ideas. And this is one that started very early on, actually. And there are two fellows who worked out a way that they felt that the tarping was the most efficient and the ways in which to install it. So this is just an illustration of what they put together. And then there's a whole page of instructions on how you do this and how you plant plants. And there are special collars we put around the plants so the reed canary grass doesn't come up. Next slide. These are the two guys that put this together. They just came up they just handed it to me one day and said, okay, this is what we do. And so we keep it in the van, and all the crews since then had been able to use that. This is an example of the way in which they lay the tarp and the wood that we leave on site. Next slide. This is Russo Creek and a private home. In 1996, the flood almost washed out that covered bridge on the top. So we came in about 10 years ago and cleared all this out. Next slide, please. And laid the tarp. And then here's the next spring. Next slide. And it's completely filled in now. You drive by, you can't see the creek or anything. And it's really quite beautiful. The landowners took really good care of it, and they were very enthusiastic about the project. Next slide. And this is, you know, they found these old fence rails on this project, and so they decided to rehabilitate them and put them together. Next slide. This is the next spring. This is what it looked like. Next slide. And then this is on the current site. You can see the stacks of chips in the background that we'll be using. And these are some of the small things that can't be chipped, which we'll also use. And then all the large pieces are laid out on the tarp. Next slide. So, you know, you get these fellows who haven't, most of them haven't had experience with plants or with planting. Some of them actually have worked in nurseries or other places, which is really kind of nice to have. And so I have to create plans or ways in which they can plant without really knowing how to lay it out or do anything. So this is what I do. I create color coding with each one of these and a number. And the plants, when they unload them, some of you people who helped me unload recently, we put them all in the same place so that the sumacs in one place and the willows are in another place and so forth. And then, next slide, and then they get these schematics and they take the schematics and set the plants out. And so this is, oh, that's okay. We'll keep, you can go on the next slide. So another strategy I've used is actually putting different color flags in each one of the different kinds of plants. If you have just a few plants, that works pretty well. And then putting out the matching flags in the areas that they're going to be planted. Next slide. This is on the Walla River at the farm labor homes. This is where we did a project a while back. Next slide. And this slide shows how we worked in town on really quite small properties and small streams. And so you can see that this is Lincoln Creek. It comes out of a spring in the park. And this is an apartment house on the left, and another house on the right. And this is all now filled in with these native plants. Next slide. So also in the areas that we're working were the ceded lands of the Confederate tribes of the Umatilla Indian Reservation. So we often have to have a cultural anthropologist with us when we're doing the planting, or in the most recent project when we're doing the site prep, because it was suspected it might be a site for the Rose Mission, where there are 18 Native Americans buried. And we did a lot of pre-work with the anthropologists on that site. So the crews in, as they plant, have to spread out all of the soil while the anthropologist watches and make sure that there are no nails or, you know, there's farm equipment or any other debris from the past. And this anthropologist gives them all really high marks about how cooperative they are and what good work they do. Next slide, please. So one of the things that they enjoy is whenever they run into something live in the creeks. These are some of the things that pictures of the things that they pull out and put back in the creeks. Next slide. And this is just a list of the other animals that they've seen. They saw otter for the first time a couple of weeks ago, and one fellow started throwing him bread, and I had to let him know that they eat fish. But they were, you know, they were really thrilled to see the otter. Next slide, please. And bird watching. I'm a bird watcher. I used to work for Audubon, and so this officer kept a bird book and his binoculars in the van. So anyway, that's just some of the examples of the ways in which these people engage. Next slide. And for a while, I was giving a, sending pictures of the crews to their families. And that was when most of them were staying on a year or maybe even 2 years. But now with the changes in the laws, they're getting out much sooner, which is good for them. But also it's harder to keep my crews together and, train them because I don't have the same consistent crew over a period of time. So this is the crew when, at the end of one of the sites. So that was generally the reward was taking a picture of everybody. I also had been giving them homemade goodies, but they bragged to other people in the penitentiary, and so it got shut down. I can't do that anymore. But I wanted to talk to you, I think, okay, I'm in my time, right? I want to talk to you about this fellow on your left here, the guy who's got his arms folded. His name is Neil. I never knew his last name. He's quite a gentle fellow, and I always gave him the little plants to plant because he was very careful with them, and I knew that they would survive. And about a year before he was to be released, I got a call from his sister in Oklahoma. And she wanted to know if I knew of any programs for him after he got out, because she was concerned because he was going back to the same community where he'd come from. And I said, well, I knew the STAR program. I didn't know where he was from. I didn't know if there was a program there or not, but she could check into that. And I said, and how did you know how to contact me? And she says, well, Neil talks about you all the time when I call him. And I just Googled Judith Johnson and Walla Walla Penitentiary. So he went home. He was taking care of elderly parents. His father couldn't hear. His mother's had Alzheimer's. And he also had a teenage son. And his sister called again about a year after he was released, and she said he was doing really well, taking care of his parents and his son, and that she had gone up to visit her parents and planted a garden and some flowers. And he said to her, Judith would have never planted those flowers. So anyway, that's all I have. The next slide, please. And just I'm sorry these slides are so washed out. In person, they really are much better. Anyway, I have a lot of partners and a very small organization, work with the Conservation District, Tri-State Steelheaders, and a lot of other people. And so otherwise, any questions?
Whatever you want to do to get to the PowerPoint slide. So we are down from Wenatchee. We made the trip over Blewett Pass. It was beautiful. Nice to have you guys here. Anybody been up north to Wenatchee before? Okay, a couple of you have been there. Great. So we're with the Skill Source office. Oh, you guys are doing awesome. Did we hand out the handouts yet?
They already
Oh, you're getting the handouts?
Yes.
We do at Skill Source. We do a lot of things. We actually have a school in-house, and these two gentlemen are part of our school. Are you guys doing high school diplomas or GEDs? What are you doing? They did that in sequence. Did you hear that? We didn't even rehearse that. So at Skill Source, we have a school in-house. We have young people pursuing high school diplomas, GEDs. We are also the WIOA training provider. So we have adults that are pursuing on-the-job trainings, going to nursing school, becoming truck drivers. So we have a lot going on. One of the things that we do through the school are projects that the youth can get in on. Now, besides the one you're going to talk about today, have you guys been in on any projects? Which one's just the, you've done the eco one? All right. We just had this, that's live. We just had the Special Olympics up in Wenatchee, and Christy, we had students help with that. What did they do?
Right. So one of the things that we do is project-based learning. So we have a lot of creative, hands-on students who have never worked before, are not really sure what the working place is like and how to be ready for that. So we want to start off in a more safe and educational environment to get them ready for the workplace. So we do what we call project-based learning. We just wrapped up our Special Olympics. The state winter games are held in Wenatchee. So our students spent about 5 to 6 weeks doing different activities, learning about disabilities, how to make things inclusive for everyone, and then supporting the City of Wenatchee Parks and Recreation Program because they help host the state games there. They went to opening ceremony, they helped seat the teams after they went across the stage. And then on Saturday, they have an event called Olympic Town, which is a place for athletes to just go and chill after they've done their competitions, gotten medals, and it's just a really fun time. And they make a game, they did crown decorating and just had a really good time. But it gives them the opportunity to do work activities in a safe environment with some staff at SkillSource. Sometimes we do community-based projects. Maybe someone needs help, downtown association needed help at Christmas time putting decorations up. So we'll take a group of students out and they just go and help different activities in our community, however we can support that. And then we have in that leadership development, we have had leadership classes in the past, and they'll go to elementary schools to read with children. And to prep for that, they go to the library, learn about the library and how that functions, what kind of jobs are out there. So we take all of those opportunities to help the students learn about different careers and exposing them to different things that are important in the workplace.
The reason we're here today is because one of the things we do, about 3 times a year, is what we call eco stewardship, and that's where 6 to 10 of you at a time, get together every day. They go to the store, they buy some Carhartts and some work gloves, and every day they pack a lunch and they get in the van and they go into the wilderness and they do things. We partner. It's really the WSU Cooperative Extension is our big coordinating partner. But they'll do things for the Forest Service, DNR, a lot of the local land trusts. Have we worked with anybody in this room? Has any? Oh, 2 of you. Great. Do we owe you money or anything? No. Okay. Good. All right. How did it go? What projects did we do with you?
Well, I have to say, I've been bragging about this work. Last November, we had winter arrive on November 3rd, snow on the ground and frozen ground, and we at the Land Trust had thousands of plants paid for and delivered to the ground. And this crew of young people, do you guys recognize me? All my coats and hats and mittens because it was 32 degrees raining drizzle and hypothermia on Monday as we all met. And these guys rose to the occasion. And they saved thousands of dollars worth of plants that planted at the trailhead. They had to hike 20 minutes onto a steep hillside, and we did 2-year-old bitter brush and 1-year-old sagebrush. I just can't tell you that hard work that we saw, and then I was able to write long letters of recommendation that they can use. So these guys are essential for helping us where we have no funding to get plants to the ground, and we get grants. So
Excellent.
it's really cool to have them here.
Thank you for that. Did you pay her money for that?
We did.
Okay. And then we've interacted with you somehow too.
Yeah, I work for Cascadia Conservation District, and we were out scoping over there on Little Chumstick Creek as well, where we were really trying to get a lot of plants in the ground, and y'all really helped us.
Good deal. What I have for you, each crew, and we've been doing this, 10, 12?
About 15
years
in some fashion.
Every crew that does this at the end has to write up their experience and put together a PowerPoint based upon the pictures they took with their cell phone or however we captured it. So I had a few years of these that I have put together, and I haven't modified them. They are as the students created them, and some of the students that created some of these are here, and so they'll be able to talk to you about what you're seeing. Mulching on the trails to make it more safe and secure. You want to tell us what you were doing here?
So we're on this trail, right? And so the trail was what's it called? Being deteriorated by like the weather, the rain and snow and stuff. And so we wanted to mulch the trails before the winter hit, so like it wouldn't just destroy the whole trail. And so that's pretty much what we're just doing the whole day, building teamwork also. Destroy the whole trail. So that's pretty much what we're just doing the whole day, building teamwork also.
Nice. And what's going on here? What are you guys doing? You're there to do eco-preservation. Looks like you're setting something on fire.
Oh yeah, and also have the energy from it, you know. And I didn't personally get to work on it, but my brother Alex, he got to what's called test out and learn how to start a fire and all that.
You got little gas stoves that you're lighting up.
Yeah.
Like whisper lights.
Mm.
And all that. You've got little gas stoves that you're lighting up. Those look like whisper lights down there. All right. All right. Oh, yeah, this coloring is really washing out there, isn't it? All right. So again, we have them working on the stoves. So you said you loaded up the wagon with bags. What was in the bags that you were hauling around?
Just coats, whatever we needed, just in case we got like too cold or whatever. Yeah, just things we needed on the trail.
All right.
Things we needed
All right. All right, you guys.
I don't know the main objective, to be honest, but we're helping I really don't know, but we're helping some dude expand like a tree line, right? And we planted like okay, a couple hundred trees. My bad for my nervousness. We did some mulching on top of that to make sure it doesn't get derooted. And then yeah.
You put down paper.
Yeah, we put down paper for that. So what's called
lay down mulch.
we lay down mulch.
You planted things in between.
Yeah.
It sounds like what we were observing before. When I saw the previous pictures, I was like, oh, this looks familiar.
Yeah.
Observing before, when I saw the previous pictures, I'm like, oh, this looks familiar. Okay. All right.
So the day started off really good, and the flow was going good, and the people we were working with, they had good communication skills. So like I wasn't really like being a nervous wreck like I am right now. And it was really nice working with the people there. And it was nice weather, especially. So we weren't sweating or anything like that.
Nice when you get that.
I know.
Like I mentioned, we have the PowerPoints from a few years, and now previous to the year they were here. One of the things they did is they got together with it was fifth graders and kind of host events where they're demonstrating things. And there's one thing in here that says helping first graders with the arthropods. You're the expert. What were they doing when they helping graders learn about arthropods? Am I saying that correctly? There's got to be somebody in this group that can pronounce that correctly. How do you say it? Arthropods. And an arthropod is an insect. Got it. All right. And they were doing something with skulls and scat. Excellent. Hopefully this was an educational experience and not the prelude to a horror movie of some kind. Yeah, it's sometimes it's a challenge, as you know, when you have a group of people and you've got 5 weeks and you have to schedule and coordinate with various organizations. Sometimes things fall through. Sometimes you have little blanks in your schedule. So they're constantly finding they have extra projects that they're going to do. But this one, I think, I remember hearing the students report out. They really enjoyed that. Not just because of the environmental part, but the fact that they were getting to work with younger kids and to be the older kid teaching the younger ones. I know they really enjoyed that. And it was a good educational experience for them.
So in the past, we've worked with this program. We've also helped at Kids in the Creek and the Salmon Festival. So it's a really great opportunity for our students to work with younger kids and and give back to their community. And often they went to the Salmon Festival when they were younger, and so that puts it a full circle for them, which is really empowering.
Excellent. And this says Kenzie's Landing. Who's talking about this one? Is this one of your slides?
So on this slide, we're at Kenzie's Landing. And so we had to hike up onto like this little hill area so we could plant sagebrush and bitterbrush. And we're just trying to like restore like the area because I guess there was just not enough for like the wildlife to eat off of and stuff. But the plants were so small that we wanted them to grow. So we had to make shrouds and put them around them so that the animals wouldn't eat them before they got the chance to grow.
I think we must have been pushing buttons at the same time. You want to advance it there? Because when I clicked it, it did something weird. Oh, here's the little shroud that they were talking about. This is a hard one for me to wrap my head around. I grew up in Wenatchee and worked in agriculture, and our fight was constantly against sagebrush. And so to be on a project a few years ago where we were replanting sagebrush, which I'm allergic to, it's a good time. You're out there putting the sagebrush back in the areas where previously you'd taken a tractor to it to try to remove it. But it is beautiful once it's there and looking all natural again, and I will go through those areas, just not in the spring. Let's see. Okay, there's the picture. All right, you want to try another one? Yeah, it looks like you're doing this in beautiful weather. Is this? Yeah.
It wasn't, but okay. So this day, we're helping two different schools. We're helping this school called Discovery and Westside, and we're showing them how to plant and what's called protect them. And so that day, we're partnering up with one person each on the crew, and we all helped them learn how to plant, and we planted bitterbrush and sage.
How to do this, and then you had younger kids come and you showed them how to do it.
Yeah.
Excellent. Now, so we know that your theme is more riparian, and am I saying that right? Riparian. Yours is more riparian in nature. So some of our projects are, and we'd like to share those with you. Blackbird Pond. You've been to Leavenworth. Anybody been to Leavenworth? Yes. If you the Blackbird Pond, that's the big one off of Leavenworth, and you typically think of that as a lot of tourists wandering around, and they've spent a lot of time the last few years trying to return it to a more natural environment. So what to Sean, this is his slide, 10-10. It's hard work, but when you're done, it feels good to see what you have accomplished. All right. And the little chum stick. So tell us, what were you guys up to here?
That day, our mission was to plant trees to help prevent the creek from evaporating. And so we're planting live stakes and trees. And there's a lot of stuff we had to do before that. We had to take up the tarps that are underneath the sheeted grass, and that stuff was really tough to get off the ground. And we had my brother, for example, he was working on brush cutting. Why do you emphasize on it?
Yeah, I was just like brush cutting a lot of long grass, and our main goal was just to brush cut it so afterwards we could plant these trees and live sticks so we could just like help the creek, you know.
That's what you got going on here. Mm-hmm. So you had tarps down over, what were the tarps covering?
So the tarps were on the ground.
We're so used to speaking just in regular voices.
So the tarps were on the ground to like prevent weeds from coming up, but this time around we had to pull them up. So like they already had like dirt and already plants growing through them, so that was super hard to cut them off or to take them out. And then with the live sticks, yeah, we're just planting the live sticks around the creek so they can have time to grow and just like help the creek out.
And it looks like you took on a pretty good sized project there. All right. And that's another one describing that. Like I said, we took the PowerPoints they created and put them together here for you. All right, and you two weren't at Sleepy Hollow, were you? Okay. Sleepy Hollow, again, is similar, only their focus had been on removing what shouldn't be there. I know I didn't get in on that project, but I heard about the rusty items and the things that they removed and spent some time doing that. Crates and pipes. And then the Beaver Dam in Davenport. So this is not a project I got to be on. And so, Christy, the students, do you know some more of the details about that one?
I don't really know any of the details, but one of the culminating items that the students do at the end of their experience is they usually go on a 3-day, 2-night work project with the Forest Service. In this particular situation, they went to Davenport, and that's where they spent their camp out. So they drove there, they set up camp, and they worked on these beaver dam analogs. And then they spent the night in tents right there and worked on that for a couple of days, and then they came back.
I've got a slide. Maybe you can tell us what they're doing. What are they doing here? Okay. Well, what's the pump with the hose hooked up to it for?
Post pounder.
Okay. Is there an air compressor or something running that thing? Got it. That would have been nice. Okay, got it. All right. As I said, this is the culmination of the PowerPoints put together by the crews. Varieties of events over the last 10, 12 years. A few years ago, we were eradicating Canadian thistle. Apparently, it's unwelcome. There was a fire in the 8 Mile area, and the helicopters they used to help put out the fire brought in Canadian thistle, and so we spent several years eradicating them. Apparently, chopped their heads off and put them in a bag. It was very gruesome. But it was just the thistle, not the Canadians. Here they're working, doing something at the fish hatchery and doing some projects there. We always involve a trip to the ropes course, so they do some team building. And these are the things we try to incorporate into the whole, 4-5 weeks that they're together?
Yeah, often 5 to 6 weeks.
Usually, as she mentioned, it culminates in an overnight. That's my favorite because any excuse to get out in the wilderness and not be in the office is great. If this seems like the kind of thing you'd like to have going on, or if something we could support for you, we have a crew about 3 times a year looking for activities. And so we have Seth's contact information. He's the coordinator with WSU Cooperative Extension. And we have Christy's contact information, who is with you today. Any questions we can answer? We got one.
Okay, I was told that maybe I should do some walking or dancing around the stage to keep us all awake this afternoon. Well, it's fun to hear about a lot of different perspectives on restoration. There are so many different methods that we use in different situations, from the process-based stuff that I was talking about earlier to kind of beaver-related processes. And the stuff that I'm going to present right now, I think easily half of us or 3/4 of us in this room could be presenting case studies of projects that you're working on. So I hope that if you have projects that you would get in touch with the Populus committee and let them know that you have work that you want to share at the next symposium, because I would love to be hearing what you're talking about. So at the end, please jump in and share your experience. So these are what I think of as like kind of bread and butter type of riparian restoration projects that are really projects that are where we have deforested areas because of agriculture. So we're working on replanting deforested areas. And so I'm going to tell you about these kind of multi-partner projects. Some of the people that worked on these projects are in the room. Some of you that went on the field trips yesterday have heard about a couple of these. Here we go. So thanks to everybody that participated in these. And I want to give a huge thanks to our Mid-Columbia restoration crew who's sitting in the front row, without whom these projects have happened or be in the great state that they are in, because they're the backbone of the riparian work of Mid-Columbia Fisheries. Okay, so the first project that I'm going to tell you about is in the Cle Elum area, and it's owned by a private landowner at River Mile 192. It's a project area that has been that was on Department of Ecology's radar for a long time. You can see this large 200-acre property that has a 300-foot-long unvegetated right bank of the Yakima River. You can see it from satellite imagery. So it's like in this forested zone of the Yakima River. It sticks out like a sore thumb. So we were invited by Kittitas Conservation Trust and the private landowner to start working on riparian reforestation along the river. And fortunately, we were guided by some work that had been piloted by the Yakima Nation a few years prior. So Scott Nicolai's crew had planted a couple handfuls of ponderosa pine years ago and hand watered them. So we knew that something was possible at this really hard site, and that's what got us going. So we got involved in this project. The main, like many of these project goals, I'm going to rush through because they're all very, very similar, is to create shading. And obviously we're not going to shade the Yakima River bank to bank, but when there's no canopy, we don't even have any bank adjacent canopy. We also want that rooted material to slow bank erosion. This project area had 500 stream feet of denuded vegetation, a rapidly eroding bank that we worked on. Other areas have riprap, so I'm not sure that that's better, but at any rate, slowing bank erosion on that one 500-foot stretch was one of our goals, and also that floodplain roughness is almost always a goal of ours, including in these floodplain reforestation projects, including just simply improving fish and wildlife habitat. Okay, so this site, as I said, was a really harsh site in terms of, I'm sorry, these pictures are, I noticed that our imagery is not super awesome today, so my apologies for not being able to see the detail that's in these photos. So the site is harsh for a couple of reasons. One is that groundwater was way down from the soil surface, so greater than 4 feet. In some areas, I'd say it was probably closer to 6 feet. And you're looking at the denuded bank on this image on the right. The soil particle size was really big in a lot of areas of the site. It was actually a former quarry pit to help build I-90. So in the area where the quarry was located, there was a lot of surface material, and that soil was also really compacted. So when we were asked to get involved in the project, my first thought was, oh, bleep. And because, you know, getting invited to work on some of the harshest sites seems like it's a running theme in my work life, and I feel like I sweat bullets trying to figure out how to make something that is super challenging work. Let's see, and then one of the other challenges we knew going in is that there was a large, there was an elk herd that migrates through the site, so we knew that we were going to have a lot of issues. I did not include the photo that had an elk print, a bear print, and a raccoon print, all in the same, like adjacent to one of our planted plants. Okay, so what we did this site was planted in 2019, and we manually installed 4,400 plants across that 9 acres. And manually meaning that we augured holes in and then planted them by hand. We used landscape fabric in some areas where we had a lot of Bromus diandrus. We didn't have reed canary grass because this is so high and dry. We did have some areas of really heavy weeds though, and in those areas we used landscape fabric. And in some areas, like this large image, we followed up the planting with wood chip mulch around each plant to suppress weeds and also retain a little soil moisture. Because of the heavy elk use, we did install an elk deterrent fence wherever it was logistically possible. There was one area of the site that we weren't able to put a fence in just because of the configuration of that subsite. And then let's see, I think one along that 500 stream foot bank, we installed those 500 plants using the hydraulic ram. WildLands did this work for us. So we basically did really tight spacing. We put 3 rows of plants in at about 2 to 3 foot spacing. So we really jammed them in, trying to get plants established as quickly as possible so that we would slow down this bank sloughing that was happening. And then because this site was so well drained and the groundwater was so low, we selected mostly transitional species and dryland species and applied drip irrigation. So we had a water source available, and that drip irrigation is something that when in these kind of typical conventional planting projects, we've moved towards drip if we have to do irrigation. It takes a little bit more to install, but then we're able to provide very infrequent and deep watering to our plants and really get that soil column wetted up instead of doing kind of topical irrigation like you would do for a lawn or a farm field if you're doing overhead or broadcast irrigation. So we do that at one week intervals during the first year, and if necessary, we do it at 2 week intervals for the second year. And on a couple of projects, we've had to irrigate for a third year. So at this project, we were able to do implementation monitoring. Some of our projects, we also do effectiveness monitoring to see how we're moving towards canopy and floodplain roughness. But the projects that I'm talking to you about today, I'm just going to show you some of our implementation monitoring. So here's one of our interns and a restoration technician in 2022 looking at plant survival. And these trees that you're looking at here are actually on the other side of the river. So this is the right bank of the river where just beyond the fence. So this is 2.5 years after planting. Our survival this last summer was a little over 70%. And after doing habitat restoration and doing this kind of monitoring for a long time, maybe I'm jaded or maybe I'm just realistic, but my threshold for success is about 50% survival. So if I have anything that's better than 50% survival, I think that we're going to be on a trajectory to have the kind of cover and density that we want to see in the future. I know that the Corps of Engineers may not agree with me in their permitting, but that I think is like a realistic threshold. So 70% to me is pretty fantastic. And in terms of our species survival, I don't think you can see that. I'm so sorry. So I had highlighted in yellow our 2 tree species, which are ponderosa pine, and that's this one right here, which had in 2022 almost 80% survival, and our Doug fir here had almost 70% survival. So super happy about how our 2 key species. So I don't have the numbers on me right now, but I think 30 or 40% of all of our plants were these 2 target tree species because we're really trying to create canopy and large wood. And that leaves us, in 2022 at over 100 trees per acre and over 300 woody plants per acre. And just kind of summing up, I'm sorry, I could talk about each project for a really long time, so it's very hard to crunch it all into 30 minutes, but maybe we'll have time to ask questions or you can share your own projects at the end. as I said, I'm really pleased with the survival and density, but one thing that is a really important caveat is that we pulled at the end of the season our irrigation. So this site is very, very young. And I'm expecting that even though we have a really nice survival curve right now, we're probably going to see another bump down in survival in the 2023 and potentially 2024 season as the plants transition to have their first year. You know, they have, because of our deep, infrequent watering, they should have established a lot of fine roots, but time will tell. So in a couple of years, you'll see. We'll see what the new numbers show us. But pretty excited about the fact that I did choose a lot of, as I said, xeric species that we're hoping we've got them going now. And will persist. Let's see. So the bank plantings, which are pictured over here, did really well. I did not monitor these for survival or density, but I am very pleased about the take that we had. I think we did have some mortality up when in that top row, I said that we planted 3 rows in high density. So at any rate, that went well. I'm not sure if you guys can see this table that I put together, but for each of these projects, as I was trying to figure out, what would I want to know if somebody was telling me about their projects? And I'm always trying to think about how to do things really well, but cheaper, or how to be really efficient and make things work. And so I thought, I would probably want to know how much this costs. So I got all my records of, planning and implementation together and all the site prep. So the weed treatments that we did and laying down landscape fabric and paying for the plants and getting them installed and paying WildLands to install those plants. And including 3 years of maintenance, which is our typical post-planting. And that came out to about $12,000 per acre. So I tried to standardize all of these in a per acre cost. So that's probably going to make a lot of people's jaw drop, but I really try to get that out to funders that this is just the cost of doing business. If you're trying to rehab a former agricultural field along 3,000 feet of the Yakima River where you've got groundwater 6 feet down. So anyway, so that's River Mile 192. Right, that's a nice photo. So during installation in the 2022. So as I said, lots of people involved. We got some funding from Department of Ecology. They provided a grant to the Kittitas Conservation Trust, which paid for the initial work, and the Salmon Recovery Funding Board is paying for maintenance. The private landowners are pretty amazing. They live on site, and so we've had to be, we are very, very well coordinated with them and really try to keep them in the know of what's going on their project so that they're as invested in it as we are. And then, Derby Canyon, WildLands, the Kittitas County Noxious Weed Board, lots and lots of folks have been involved in making this project work. Okay, the second project I wanted to show you is at the Yakima River. This is one of the ones that we went to in our site tour yesterday. It's the Yakima River at roughly River Mile 149 on Ringer Loop Road. And one of the cool things about this project, as I said yesterday, is that it occurs within a large kind of 4 mile long planning reach where there's some levee, and actually longer than that if you include the areas up above where there's floodplain reconnection being designed to allow the river to migrate in this area, to implementing as a colleague, I think, from the Department of Transportation spoke this morning about the importance of long-term planning efforts to work on being able to set back levees and allow these big projects to happen. So at any rate, on this project, we had 2 different kinds of restoration going on in the yellow polygons, and those are actually yellow right now. That's awesome. are about 5.5 acres of riparian reforestation on both BLM land and Kittitas County land. So those are areas that were denuded. They were selected collaboratively with the BLM to reforest areas that had been deforested when this was private land. And then in the orange is a separate method that I'll talk about of floodplain restoration. That's really a two-phase reforestation. Our goals are really similar: shading, roughness, slowing bank erosion, also really include in creating a source of large wood over time, especially as we're hoping that river migration is able to happen in this area. Okay, this is a really geomorphically active reach. In the presentation I gave this morning, some of the slides I showed were from this area. It's an area of upwelling right before you hit the Yakima Canyon in the Kittitas Valley. So it's where a lot of tributaries and a lot of groundwater, shallow groundwater, kind of come together and are pushed up as everything kind of bottlenecks before it tries to go through the Yakima Canyon. And actually, in our image, this is the Yakima Canyon, right? Let's see. There we go. There's the Yakima Canyon right there, for those of you that are not as familiar with the Kittitas Valley. So this is the Yakima River right here, and part of that geomorphic or fluvially active zone is that we've got this actively avulsing path right here where even in the last, I think 20 years, the river's probably moved over 50 feet and has now taken a ringer loop road. And for those of you that were there on the site tour yesterday, this is the turnaround that we parked in, and it's a turnaround now because the road down here is being taken by the river. Okay, so anyway, shallow groundwater, and because we're in a floodplain, we've got loamy soils with a lot of cobbles and gravels. And in the western sites here that are where we've got denuded banks right on the river, one of my colleagues, Mike Bosco, who's here, looked at aerial imagery and was able to show that that we have in the last 20 years, we have an average of about 5 feet a year erosion. Bank erosion, so it's moving pretty fast. Not 5 feet every year, but that means that some years it might be 10. And then, as I said, this is an avulsion pathway in this former agricultural field that is now owned by Kittitas County because of they picked it up because of the flood issues here and flood risk. Okay, so in those western yellow polygons that I showed you, what we did is, we, meaning Mid-Columbia, collaborated with the BLM and BFI. Katie Fitch is here and was able to talk about this project yesterday at the site tour, and planted about 2,000 plants using an auger planting method. This is the avulsion site right here, Yakima River. So in that 5.5 acres, they were planted into strips, augered anywhere from 2 to 4 feet down, and we selected those deep planting adventitious rooting species that are willows, aspen, alder, and black cottonwood, and dogwood. And then we installed in one area of the site, this area, which is a little further back from these public use areas, that there's a lot of deer and elk browse. So we saw that in the first year, deer and elk were keeping our plants to about 6 inches high, compared to other areas where dogs and foot traffic are really keeping the animals away. So we installed, or rather Mid-Columbia restoration crew installed an elk fence in 2021, and then in fall of 2022, WildLands installed another 1.5 acres of plants, and I don't think I have that image, but they installed another 1.5 acres in that big 3.5 acre area using the stinger planting. And we actually, we were talking about this yesterday, but there is the video of the hydraulic ram stinger planting that we used in 3 sites and will hopefully be using in the 4th soon, is now up on the Mid-Columbia YouTube page. And then because these are deep planted, there's no irrigation necessary, which is lovely. So really the major challenge at the site in maintenance is weed maintenance. And there is quite a lot of that because all these plantings were into reed canary grass, and the productivity was, or actually I should say that, yes, they were all planted into reed canary grass and the productivity is pretty high. Okay, so what did we find? Across the whole site right now, we have an average of 78% survival, which again, to me is kind of crazy through the roof. I mean, we have a couple of sites right now where I feel like, am I going to be in that awesome position where 10 years from now we're thinking, do we need to go out with chainsaws and thin these things? I have yet to be in that position, so it would be pretty interesting. So we also looked at species survival of our dominant species, and at 2 years, we had really high survival of our 2 willows, coyote willow, and so in the green bar is the 2021 survival, and the brown bars are 2022 survival. And so for coyote willow here and for peachleaf willow here, we had super high survival, same with our black cottonwood. Lowest survival was, again, close to my 50% threshold, is red osier dogwood. And our one transitional species was chokecherry. And the thing that is not represented that I mentioned yesterday is alder, which we also planted a lot of, but somehow didn't get picked up in our monitoring. And we planted at those 4 subsites that I showed you, and there really was no big difference in overall survival. So we still had roughly the 70 to 80% survival at all of our sites, all 4 of those subsites. Okay, so I wanted to talk about the other type of rehab that we're doing on that 32 acres, and again, led by BFI and their expertise in native bunchgrass rehabilitation. So when the field was acquired by Kittitas County, we immediately wanted to start rehabbing it and transition the site from this annual and perennial weed bed with some residual alfalfa, and move it towards something that was perennial and deep-rooted and would withstand flood events. So that essentially was moving it to native bunch grasses, Limus cinereus or basin wild rye is the dominant grass, but the species mix that was recommended by BFI included several other species. That just is the one that seems to always push its way to the front, is basin wild rye. So the work that we did there included chem fallow for a year, and then in 2018 it was disc smoothed and then no-till drill seeded in 2018. And so this is you can see the no-till rows here, and in 2019 we had a really good stand. Now, what as I said yesterday, we had about 9 acres that either didn't take because they were, we had some weed issues or some ponded water issues, or we had areas where we had really pernicious weeds and needed to treat them for another season. And so we seeded those those 9 acres in 2020. So the maintenance on this, on the seeding, looks like ag type of herbicide application, broadcast herbicide application using dicot specific herbicides, because grasses are a monocot. So if you use dicot specific, then you're not going to harm your grasses, which is cool. So that's kind of for anybody that does this, that's kind of the bread and butter grass rehab approach. But it's pretty neat that we can use biology to kind of tweak our methods. Okay, so in terms of the grass seeding, the species that we saw coming up as dominant species across the site, where we had the highest occurrence in our sampling plots, was the spike bent grass and slender hair grass. And our basin wild rye in this first year was kind of, not taking over the whole site like it is now, which is actually okay. It's a great workhorse. It has like 9 foot, it can have roots that are up to 9 feet deep, and just an incredible and super robust stout plant that does not like lay down unless it's like super, higher velocity flows. And then we had a couple of like what I think of as wet meadow species, red fescue and meadow barley. So in that first year, we had 40% native cover. What I'm not showing you here is that our implementation monitoring showed that we had about 19 seedlings per square foot coming up in the first year, plus or minus 4, which means that we're way beyond the threshold for success. A lot of our contracts are warranted at 3 seedlings per square foot for success for our contractors, and so it's really cool in your first year when you're like way above that, especially knowing that you're only going to have about 10% of those in your second year. So if you start out with almost 20 in your second year, you're going to have almost 2, and that's pretty good. I mean, think about how many bunch grasses you see per square foot, and it's usually less than 1. So anyway, we were in really good shape, and that that site's looking really awesome. I don't know if I'm going to get back to that, but if I don't get back to it, I will get back to phase 2 before we leave this site. Okay, so I wanted to kind of go over what we saw here. One of the things I wanted to point out about the western area riparian plantings is that, we saw that initial elk pressure, and where those plants are being browsed really, really short. And in another project, we also saw deer browsing trees really, really, about 6 inches, and had high mortality because of that. And that was documented in another monitoring project. And so we jumped into action and asked for more money and put a fence around the plants. Well, if you looked at that survival, I told you that we really didn't have huge differences in survival rates between the planted areas, and one of our planted areas is the one that the 3.5 acre one is the one that was fenced. So I'm definitely like in the place of wondering how much money we should spend on fencing. I mean, I don't, when you get to like the per acre or the per plant costs, they're really high. And so losing a bunch of plants to me is really not, like, that is a non-negotiable. But anyway, that's kind of a more of a something that I continue to think about, is like how much herbivory and how much mortality can we stand, and at what point may those 6-inch plants make it, or may, anyway, it's all very site specific. So it's probably just going to keep me up at night and not help me move my projects forward. And then planting in rows, Katie brought this up yesterday. Planting in rows is definitely something that Mid-Columbia does a lot of right now. When landowners can tolerate that, it doesn't look awesome, it doesn't look natural, but it sure makes maintenance easy, especially if you're, you have a lot of weed management, or if you're irrigating, like the first project I showed you. We're also looking at alternatives to landscape fabric. Landscape fabric is kind of in reed canary grass is a necessary evil, but it does need to get pulled up, and that's on our docket for a couple of projects this year. So that's a lot of work. It's additional funding. We're going to apply native bunchgrass seed and straw over the top so that we're putting something into that bare soil that we're creating again. And hoping that we also get a little bit of shading from those larger plants. But we did, one of my colleagues, Carson Brisky, spent some time looking into other materials that we could use, like thick coconut fiber matting and things like that. Well, we haven't found anything that costs less than I think we found something that was like a 3-foot by 50-foot roll for only $300. So, we're definitely, we haven't found that silver bullet yet, but always bouncing between wood chip mulch as an option, landscape fabric as an option, do nothing as an option. But no, any rate, could go on. Okay, and then in terms of, so here's our total cost for that planting. This one was a lot higher, probably because we had that mechanized planting of including our maintenance and everything, about $23,000 an acre. And then in terms of our floodplain re-veg, so as I said, we did have 1 to 2 areas that we needed to reseed, and that's just kind of a rule of thumb is when you are doing a floodplain bunchgrass seeding project or an upland bunchgrass seeding project, make sure that you're planning for necessary reseeding, because there's going to be an area that fails for one reason or another, or you could, like we had up in the Tianaway in spring of 2021, a super dry spring that you just don't get a lot. Where was it? Spring of 2020, Katie? I can't remember. I think it was spring of 2020. One of the springs was really dry, and we actually had 2 projects fail because we just had such low precip that year. So sometimes you just, these are irrigated by nature. Thank you, Tori. Okay, and then floodplain, let's see. So then the phase 2 of this project, which is really the really cool thing, is that, we're not intending to have just a bunchgrass floodplain forever. The issue is, the point is to stabilize it in native grasses and then plant our trees directly into those grasses. So instead of doing what we often do, where we're planting our trees into weeds and trying to suppress them with something, instead we don't have to suppress anything because we're planting them straight into these established, stabilized situations. So WildLands is queued up to do that as soon as we, hopefully in that sweet spot when we get cultural's approval this spring and before it floods. So we'll keep our fingers crossed for that. So here are our totals for per acre for that 32 acre seeding. And again, these were like, I don't know if you should quote me on any of these numbers because they are my best estimates based on our, all of our billing and what have you. But these are not based on my careful totals over the 5 years of the projects. Okay, so I just wanted to thank again our partners. So these projects are all collaborations between Bureau of Land Management, Kittitas County Public Works, and coordinated by the Yakima Basin Fish and Wildlife Recovery Board. And they would not be possible without the folks that are doing the work on these projects, like Kittitas County Noxious Weed Board, and Mark Eiler was here today. So thank you, Mark, for your support of these projects. BFI, Katie Fitch, and John Cotton are here, Derby Canyon, and of course, WildLands. Thank you. And this is really cool, June 2022 flooding. These are some of the plants that were put into the avulsion area, you know, what Katie referred to as our spillover site. So it's really cool that we have a tiny bit of roughness in that site. And here's our floodplain being, floodplain bunch grasses being flooded in 2022. Okay, the last project that I wanted to show you is Wilson Creek at River Mile 3.5. And this is a roughly 5-acre project. I'm sorry that the images are so hard to see, but this is a 5-acre project along Wilson Creek. For those of you that were on the site tour, we were kind of standing yesterday right off the image on the far right. So this is our main stretch of creek, and then there's also some more that's in the project area down here. So the primary goal for Wilson Creek is it is impaired by temperature as well as sediment. It's a really important, lower Wilson Creek is a really important fish-bearing stream. So it's definitely on the radar of most people working on fish-related habitat restoration. And Kittitas County Conservation District initiated this project with a private landowner that has a working farm along this creek, this stretch of creek, and supported it initially with NRCS funds. So they invited Mid-Columbia Fisheries to get involved with the planning and implementation of the project. So the site is pretty cool. It has these inset floodplain benches that are really like a half a foot to a foot above low water, and then these low terraces that are 1 to 3 feet above low water. The project was planned by the Conservation District to not need supplemental irrigation because it is a farmed area and they have pivot irrigation. So there was an assumption that just getting that incidental water from the pivots would be adequate. But in the first year, our restoration crew was really on it and watching what was going on with the plants, and saw that even though they were getting some irrigation water, again, that frequent top dressing water, there was a lot of leaf wilt happening. And so we jumped into action and put in drip irrigation on the parts of the project that that were up on the terrace, and that was these larger polygons here, and then in the southern area. So the site also has loamy clay soils, not a lot of cobbles. One of the issues that is going on, I think you can't quite make out the pivot line here, but there's a pivot line that is connected right here and pivots back and forth. And then there's another pivot line up here. And because of the active pivot lines and the guns, the irrigation guns that run off of the end of the pivot lines, the landowner was requested that all the plants from here upstream were short enough that they weren't going to interfere with the irrigation going over the creek. So all of those plants were selected by species that are going to not exceed 15-ish feet. So like coyote willow and some of our shorter willows. And then we put in some cottonwoods and pines in these taller areas here. We're also coordinating really closely with the landowner on weed management and access areas because it is an area of his livelihood. So here's what this NRCS practice that was applied looks like. Again, we didn't have a ton of latitude in the methods that we used in that first year of planting because of the NRCS funding. So they required NRCS practice required application of landscape fabric and then putting these mulch rings on top of it. And then they also needed to have these browse guards, which we typically don't use because they blow off and then end up in the creek. And then along these inset floodplain benches, the landowner combined with the noxious weed board burned and then treated the reed canary grass before we put landscape fabric on it, not because we thought we were going to kill and eradicate the reed canary, but just to suppress it for a couple of years so that those live stakes that were installed could get their roots established and start growing. So we planted 1,200 container plants into these upper terraces, and as I said, installed drip irrigation for that deep, infrequent watering, and then installed in 2020 550 live stakes, and then and that was only on the east bank. So we didn't have a whole lot installed on the west bank. And when we were assessing the project to see how plants were growing and were we achieving our goals of getting good cover on Wilson Creek, we saw that really, the most important thing is getting plants established on these two inset benches. And so we engaged with WildLands to plant the west bank of, essentially all the areas in purple that had really, really sparse woodies. So let's see. Here they are planting into that reed canary grass. So in terms of other things that you can try is installing tall plant materials. So these stems were 4, 5, 6 feet, 7 feet tall, and with 14-inch plus roots. And so those roots were installed below the sod mat of the reed canary grass. And hopefully when they start leafing out, those leaves we'll have some leaves that are up above the reed canary grass and already be able to compete with it. Okay, and then one of our primary, as I said, we're doing, in terms of maintenance, we're doing drip irrigation, which is done as of this year on the terraces, and then just ongoing weed management. So what did we find at this site? We have, again, 70% seems to be a theme, which is nothing that I feel like I'm not really responsible for that. But I'm really excited about it. So we have about 70% average survival shown in this red bar, and then most of our in 2022. This graph is showing us species survival. I'm sorry, it's 4-letter codes that you probably can't read from back where you're sitting, but the important takeaway is that the highest survival are in those transitional species like serviceberry, choke cherry, golden currant, woods rose, and lower survival in some of our woody species like red osier dogwood, black cottonwood, and that's largely because of the herbivory that is driving down both survival and growth in those species. Those species, I didn't show you the height graph, but essentially all of the species are losing height over time because these are not fenced. And then the last thing that I wanted to show you in terms of what we know at this site is that live stakes are phenomenal at almost 75% survival of those installed plants, which I never see. So just wrapping up, Tori, one of the big takeaways that I have is that probably our biggest challenge, one of our biggest challenges, and maybe if we have time, the restoration crew can chime in, is that weed management at a site that is tilled and an actively managed farm is really challenging. We have a lot, like super abundant weeds. It's a highly productive site because the groundwater is shallow. And it seems like every time we turn around, there's another weed management issue that we need to keep clean because we've got a landowner who is really invested in not having a weedy mess adjacent to his farmland. And then, of course, as I said, I'm thrilled about how the live stakes worked. So our total per acre cost came in about somewhere in between the other two sites at about $15,000 an acre, including, so this is like over all 5 years. And just a thank you to the Conservation District Salmon Recovery Funding Board is funding the maintenance on this project. So thank you very, very much, because NRCS does not fund maintenance, and this project would have been an abysmal failure if the Recovery Board had not agreed to take this project on. And to our partners that were the Noxious Weed Board and WildLands that were really critical in making it a success. So I know I'm over on time. Thank you for your patience, Tori. And I would love to hear from you guys. I know that like anybody could have stood up and told us about your project. So I'd love to hear from you or hear questions. Thank you.
I'm Landon Schaefer. I'm a part-time employee with Mid-Columbia Fisheries Enhancement Group, and I'm also a student in a graduate program at Central Washington University, the Cultural and Environmental Resource Management Program. I'm super excited to talk to you all today about the preliminary results of my thesis research that I've been doing for the past couple of years. And the title of my presentation is Salix fragilis, Influence of an Exotic Tree in the Kittitas Valley. We're all super familiar with the ecosystem services that are provided by riparian forests. We know that they provide shade to keep water cool. They help facilitate nutrient exchange between terrestrial environments and aquatic environments. And they also act as corridors or highways for migratory terrestrial and aquatic species. In a strictly land management purpose, they act to attenuate high flood flows and mitigate downstream effects during high water periods of high water. Unfortunately, the ecosystem services provided by some of the riparian areas are somewhat at risk because of invasive species, particularly invasive plant species. One of the biggest things that can happen when we have invasive species be introduced into our riparian areas is we can see structural and functional changes over time. A really good example I like to use is if we have an invasive tree come in and outcompete some of the native assemblages that we're used to seeing in our riparian areas, it can actually change the organic inputs into the stream environment such that it might actually change the entire suitability of the habitat associated with that certain stream reach. And the science is pretty clear that invasive species are a big problem overall. And depending on the area that you're looking at, the effect of invasive species can be different, but we do know that we want to manage for them because most of the invasive species issues is direct result of globalization and human influence. So if we look at the last couple of years and we look at invasive species as a whole, both animal and plant, we're spending approximately $26 billion a year trying to manage these things. It's a lot of money. It's really important to us, so it's important to better understand why these things are happening. Have you seen this picture yet? No? That's me. Anyway, I was like this. There's one particular invasive species, or sorry, I shouldn't call it invasive. There's one particular exotic species that I want to focus my conversation with you on today, and that's Salix fragilis, or more commonly referred to as crack willow. It's a willow species that comes somewhere from the continent of Eurasia, and it's expected to have been introduced to the Kittitas Valley approximately in the early 1900s. Originally planted along canal channels to try to stabilize banks in the super diverse floodplains associated with the Yakima River. It, along with two of its close cousins, Salix rubens and Salix alba, we have a pretty intense network of crack willow instances all throughout central Washington. And there's actually instances of it in the western part of the state and all the way over in Spokane as well. Has anyone dealt with crack willow? Is anyone interested in crack willow? Hopefully. Okay, cool. Well, for those of us who have had the opportunity to work with it, we realize, or we're coming to realize, that there's lots of management issues associated with its presence in our riparian forests, especially in the context of it being in urban areas like small towns like Ellensburg. One of the biggest issues is its very aggressive and effective root growth. Sorry, I forgot. Oh yeah, so unlike a lot of its cousins that are native to this area, its roots are actually able to grow deep into the center of the stream channel, and it ends up binding up some of the really important gravels that we associate with like spawning fishes, and it sort of ruins the habitat suitability for a lot of the big restoration efforts that we are doing in the name of some honored species. Another thing that it's associated with is flooding. Because it lives up to its name. As it grows bigger, it becomes less strong. It breaks, cracks, and then because of its vegetative form of reproduction, it's able to spread quite effectively in downstream areas of high disturbance. And it's become such a nuisance to some of the land managers in this area that the Washington State Noxious Weed Control Board is actually monitoring it and monitoring its spread throughout the state. And it is considering listing it as an invasive species in the future. And based on some of my preliminary research and the research of others, this listing may actually be valid. For example, this study conducted in 2017 on an Argentinian river called the Azul River attempted to monitor the spread of crack willow over time from 1966 to 2012. And what they found was, based on old aerial photography of the area, that the willow had actually come to dominate approximately 70% of the total canopy along the floodplain in this river system. More than that, it actually allowed somewhat uncommon species to riparian floodplains to establish and associate with it. So not only was it binding up these typically loose gravels associated with these floodplains, but it was also changing the entire structural component of the riparian assemblages associated with this river. And when we think again of like ecosystem services, we tend to think of how the structure and function of these ecosystem services is bettering or worsening stream ecology. And when we have big structural change, as we've seen in this instance here, we can imagine how potential energy inputs from the different species that are now associating with these areas can completely change the energy, the trophic levels the energy as it moves through the different trophic levels within this type of system. Oops, can I go back? Oh, wow. Okay, so the second study I want to point out to you is, instead of looking at the structural component of riparian forest, it's more so looking at the functional components that crack willow diminishes or doesn't diminish from a riparian forest. In this particular study, they wanted to compare the decomposition rate of crack willow compared to a native species of riparian tree called chiquet. This is another Argentinian study. What they did was they collected leaves from both crack willow and from chiquet, and they found 3 different stream reaches that had instances of crack willow domination, I guess, within the riparian areas. And then they also found areas along those same streams that had no instances of crack willow. And then they put these leaves in and they measured decomposition rate over time. And what they found was there's actually no difference between the rate of decomposition in the exotic reach, so the reach dominated by the crack willow, and the reach that was of the native assemblage. And the idea there that they ended up concluding was that crack willow may actually be able to fulfill the same functional role as the native riparian tree, which in terms of overall net functionality and like how energy is flowing through the stream, is pretty interesting. It may be an indication that maybe this tree isn't quite as bad as we think. The second thing they found was actually that the Salix fragilis leaves, or the crack willow leaves, decayed significantly slower than the leaves of the native plant. And that can be for a number of factors, but the big reason they pointed to was that Salix fragilis leaves tend to be tougher than the leaves of the other species. And they also have these compounds in them called phenols, which is essentially a compound that deters herbivores from eating it, that remain in the leaves as they fall into the streams. But as that decays over time, these things, these leaves, these crack willow leaves become more bioavailable. And then the idea is, in the interpretation of these researchers, that it may actually still be providing longer amounts of organic input for longer durations over time. So it may even be a net benefit to these systems instead of a net negative. This final study also looks at leaf decomposition, but this time in Australia. And instead of looking at decomposition rates, it looks specifically at microbial assemblages or biofilms that accumulated on crack willow leaves and accumulated on eucalyptus leaves. The idea being here that primary production is super important for like the most basic forms of energy within stream environments. And the more energy that's produced by these primary producers, or the autotrophs, the potential upstream energy, more upstream energy that we would see overall in the system. And what these researchers found was completely counter to what we just saw in the previous study. They see that the general production overall on the eucalyptus leaves, so on the native leaves, was significantly higher than that of the crack willow leaves. And similarly, that was A. This is kind of hard, maybe hard to read. B was looking specifically at chlorophyll A, which is like a primary component of photosynthesis in plants, and the overall chlorophyll A synthesis in these algal assemblages within these leaves was like 100 times higher on the eucalyptus leaves compared to the crack willow leaves. So when we think about that in terms of energy, again, in terms of functionality and like food web processes, we could imagine what this stream system would be like without eucalyptus and replaced with crack willow. We could completely change the total energy flow throughout the entire system and cause huge, probably detrimental effects to the animals that actually are able to take residence in these types of streams. So the literature is kind of mixed, I guess. But as I continued reading this, and as I was doing my preliminary research to try to figure out what exactly I wanted to do for a thesis, I realized that even though there's plenty of research talking about crack willow on kind of a global scale, there's really very little interesting research in the United States. And if I zoom in even closer and look specifically at our area in the Pacific Northwest, there's almost nothing. So that kind of gave me a good idea. I was like, let's look at that. And I wanted to ask a very specific question, and that is, how does the ecological structure and function of our riparian forests here in the Kittitas Valley change when crack willow is introduced? To answer that question, I needed to break it up into 3 smaller driving questions that could help me make it a little bit more manageable, I guess. So I wanted to ask 3 different things. How does crack willow presence affect the plant biodiversity of our riparian forests? How does the presence of crack willow affect solar attenuation, or the amount of shade that reaches the stream when crack willow is present? And third, how do decomposition rates of crack willow leaves compare to black cottonwood leaves? And how do those decomposition rates change in reaches that are dominated by crack willow? To do that, I needed to be able to come up with a paired research design. So one where I identified streams that had both crack willow dominated reaches and native assemblages together on the same creek. And if I could do that, then I could create a statistical model that allowed me to compare those fairly easily. Unfortunately, with the help of Google Earth and some of the free available NAPE imagery from 2021, I was able to stare at computer screens for way longer than I should have to get a better sense of what crack willow looks like from aerial photography. And this is sort of a hard figure to see, but there are different numbers here, 1 through 10, and those are the SETI reaches that I was able to identify through that process. And after doing some landowner outreach, I was able to get access to these 10 different sites. Oh, there were 5 total streams and 10 total reaches that I used in my study. Coleman Creek, Mercer Creek, Nanum, Wilson Creek, and then 2 side channels of the Yakima River. So the first question I wanted to answer was that of biodiversity. How does biodiversity differ between crack willow dominant reaches and the native assemblages? To do that, I needed to randomly select a starting point to set up my monitoring. And after I did that, I created a 100-meter reach that was my study area. And then from that, I laid out quadrats that were 10 meters by 10 meters at predetermined points, 0, 50, and 100 meters. And then I basically just counted riparian shrubs and trees within each of those quadrats to get this thing called a Shannon's Diversity Index, which is like a very common ecological metric for biodiversity. I did that for all the streams, and then I made some fun little figures. When we take like the most high-level view of the results of this study, and we just look at the streams and the difference in biodiversity between these streams, we see exactly what we would expect when we're looking at streams and when we're doing stream ecology. Tons of variation. Streams are all different. Each one is unique. It's like our fingerprints or something. It's really cool. And it's really hard to do ecological research, which I'm learning as I do this master's program, because of all this different variability that you have in nature. The big takeaway here is that there's just difference in biodiversity between these reaches, and that can be for a number of reasons. Probably land management associated with each of the different reaches that I was studying. If you want to take something away from this, Wilson Creek has the least biodiversity, and Nanum has the most. Things get a lot more interesting, though, when we zoom in a little bit and we look at the interaction between each stream and each reach, the Cottonwood and the crack willow reaches. The Cottonwood reaches are identified here with the black circle, and the willow reaches are identified with the triangle. And what we can see is there's a general trend across all of the streams that were included in the study where every single Cottonwood reach had greater biodiversity overall than any of the willow reaches. And then when we start to think about how does that potentially affect the function of these riparian systems, and we start to think of energy inputs and variability in the types of leaf matter that's being contributed to the stream, and the type of bird assemblages that might be interested in taking up residence in some of these areas, it starts to become more and more concerning, because the biodiversity aspect of these reaches is one of the major contributors to the ecosystem services that we come to expect from riparian areas. And when I zoom in even further and look at all of the data in Cottonwood reaches versus willow reaches, we actually get a significant difference in between those two types, where the biodiversity index is much higher for Cottonwood reaches than the other. Pretty interesting. I can't explain it in totality yet, I'm sorry. The second big question I wanted to ask, or try to answer for you, is there a difference in solar attenuation between those two different types of reaches? There's lots of different ways to measure solar attenuation. If you look at the picture on the right, that's just a photo from the middle of the stream looking at the canopy. Usually that's done with the hemispherical lens, and then you can run it through a computer program and basically get the amount of solar energy that would hit that spot throughout an entire year. You could also use a point density analysis with LiDAR, and you can map out entire canopies using basically just LiDAR, a backpack LiDAR, and a drone. And these little things called quantum sensors that measure light pulses through time. I chose to use this little instrument here on the left-hand side, your right-hand side, I guess, called a PAR sensor. PAR is photosynthetically active radiation, and that's essentially the wavelengths that we associate with photosynthesis in plants. So it just picks up pulses of light in those wavelengths, and that way you can calibrate it and measure total amount of light that hits a stream over time. So I use the same points that I used for my biodiversity point, except I put these in the middle of the stream. I put 3 out per reach across the entire stream, and I measured it for a period of 24 hours. And from that, I was able to take some averages of the total amount of PAR over that time period, and then run a statistical model based on PAR average times the interaction of stream and reach. And again, if we just look at the superficial level of creek, we see exactly what we see in the biodiversity. It's not that these numbers are the same, it's just that there's variability between them. Again, that's totally expected, except for Nanum, which is much higher than the others. But for those of us who are familiar with the area, Nanum, especially in the upper part of its watershed, is a much wider creek. So it's to be expected that it would get a lot more solar attenuation in that area. Also, micromoles quanta probably doesn't mean much to you. But if you think about this in terms of primary or secondary order mountain stream, that we have, where we'd have tons of coniferous canopy and very dense riparian vegetation, those areas would typically have a value of approximately 20. You know, those are pretty small streams. We're getting about 50 on average overall across the streams. So it's still, we're getting good shade in the lower parts of the valley for the study. Again, though, when we break this down by reach, we can start to see our trends develop. Again, the symbology here is the same as it was before, where the trend that we're now seeing is that the cottonwood reaches are actually contributing less total shade to the stream compared to the willow reaches. Nanum is weird. I haven't figured that out yet. But then, if we zoom in just one more layer again, and we compare the totality of the two data sets, we can see there's not actually any significant difference between these two. So I think if you take anything away from this figure, it's probably that trees are good at making shade. All right, the final part of my study, and the most time-intensive part, has been the decomposition part. And this is very similar to the study I described earlier. What I did was I went and collected senesced leaves in the fall from black cottonwood and from the some instances of crack willow that I knew existed around the county or around the valley. And I took them all to my house and laid them out on a tarp in my living room, much to the dismay of my wonderful girlfriend who's in the back. Thanks for dealing with that. Thanks. Yeah, I do. After they dried, I weighed them out to about 4.5 gram increments, loaded them into these little red leaf bags, and then distributed them to each of the 10 reaches that were part of my study. So I put 27 bags for each species at each reach. It's about 540 bags I put out there into the world. And hopefully I didn't contribute too much microplastic during the study, which I did. Yeah. You should listen to her talk sometime. Anyway, so then once these things were deployed, I'd go out and I'd collect 3 bags per given time. All these times were predetermined. And over a period of approximately 60 days, I collected all these bags, processed them, dried them, and then I was able to make a figure based on mass remaining over time. Oh no. Well, this is a figure that shows mass remaining over time for willow. This is the crack willow. And then there's actually an identical line right below it that you can't see right now. And this is exactly what you expect in a leaf decomposition study. Leaves are full of all kinds of fun little nutrients, and as they hit the water, they leach very quickly, and they lose a lot of mass really quickly. But then over time, which is kind of common of exponential decay, things taper off and slow down. But the big takeaway from this figure is that there's no difference really between these two different leaf types overall. They both decay at approximately the same rate, which indicates that they're potentially providing the same functional organic input as one another within these riparian areas. As I've done on all the 2 other questions, I'd like to just look at exactly what's happening in each of the streams overall. And what we can see here is, again, there's tons of variability. The flow is different in each of these stream reaches. Areas where flow is less may have froze and may have slowed down decomposition. There's also potential huge differences in the water chemistry based on adjacent land management practices. I'll be incorporating all of that stuff into these models eventually. If you want to take something away, Wilson Creek had the fastest decomposition rate. Like the more negative, the faster it's decomposing. And the Yakima side channels had the slowest decomposition rate. But with everything else, the closer we zoom in, the more we can actually see. And we start to see trends develop where these white bars are cottonwood species and these gray bars are the crack willow. And we see there's a general trend overall where cottonwood seems to be decomposing a lot faster within each of the streams than the crack willow does. This could again be a direct result of like the phenolic compounds that exist within these leaves, or it could be something else like the potential or the bioavailability of the nutrients within each of the leaves, or preference by the macroinvertebrate assemblages within these reaches as well. It's really unfortunate that this slide didn't show up. I tried to make it accessible for people who are colorblind, and then it didn't even work. I'm trying to think of how to explain this to you. We're looking at the willow right now, right? And it's what this figure is showing is in the cottonwood reach, the species willow is decaying significantly slower than it does in its own reach. So there's something about the willow reach that is creating a situation where these leaves are decomposing faster. If you can imagine, if I had a thing, cottonwood, oh God, can you hear me? No. The cottonwood did pretty much the same thing in this situation, except it was decomposing slower than the willow in the cottonwood reach, and then faster in the willow reach. Hello? Really, this is like the biggest takeaway of my entire research, but I haven't really figured out how to describe it yet, because to be able to describe it, I need to do a lot more research, and they just don't have enough time for master's programs. I'm just kidding. Anyway, I forgot where I was going with this. I'm going to go on. So what are the big takeaways? Crack willow and cottonwood are significantly different in the amount of biodiversity between those two different types of reaches. Areas that are dominated by crack willow have much less biodiversity, and that's potentially concerning overall because of the functional implications of having a more diverse leaf litter input into stream ecosystems. When we look at just the canopy and we're looking at the shade contributed by both of these species, there's no functional difference. Crack willow and cottonwood, as two different types of trees, are both contributing a good amount of shade as far as riparian forests are concerned. And then even though overall there was no statistical difference between crack willow and black cottonwood as far as on a head-to-head, we did notice that the reach plays a really significant role in how quickly these things decompose. And that could be indicative of the bioavailability, again, of the nutrients within these leaves, or more specifically, the biodiversity found in the plant life of those reaches. It may be that there's having a greater variability of leaf input into the stream in an area that's very biodiverse allows the macroinvertebrate assemblages to be a little bit choosier with the things that they choose to eat. I gotta do a little bit more reading on that. This is a management conference, so I thought I would say something about managing the species, because we are thinking about listing it as an invasive in the future. And I guess just based on what we know about its reproductive success and how quickly it can take advantage of its vegetative reproduction, if we do decide to invase it or list it as an invasive species, we should definitely focus on a top-down approach in our treatment of this plant. Because if we don't start at the upper parts of a watershed, it's very likely that these things are going to come back in and just continue to take over and dominate like they've already been doing in the valley. Also, we can't disregard the amount of functional shade that these things are providing, especially in light of a changing climate. If we're going to treat crack willow in some way, maybe we kill it in place, or maybe we leave half a stand to try to preserve some of that shade that it's producing for these different creek environments. And while we let our native plants grow that we've planted, then we can come back in 10 years. So we just try to take more of a phased approach, and that might be a good way to go. There's definitely more to come on this and a lot more information to find out. That's about all for me. I just want to thank a few people. My thesis committee, a bunch of landowners, Mid-Columbia Fisheries for letting me do this talk today, and then Central Washington for letting me into the program and giving me money to do this research. Thank you.